What if I told you that the universe isn't built from things, but from relationships? That distance is an illusion, and what you think of as separate might actually be two sides of the same unseen thread. What if I told you that the atoms in your body could be linked silently, instantly, with particles halfway across the galaxy, and that your thoughts, your presence, even your attention, could ripple across space without ever moving an inch? This isn't science fiction. It's quantum entanglement, a phenomenon so eerie that even Einstein called it spooky action at a distance. And over the next 4 hours, we're going to dive into the deepest cracks of reality, the points where logic stumbles, space collapses, and the very fabric of existence begins to shimmer with strange, silent coordination. So if you're ready to challenge your concept of individuality, to question whether you're truly alone inside your skin, and to explore a universe where connection isn't metaphor but physics, tap like, hit subscribe, and step into the haunting beauty of entangled reality. Quantum entanglement. Spooky action at a distance. Imagine two mirrors placed so far apart they can no longer see each other, yet still manage to reflect one another's secrets. Not through light, not through sound, but through something that defies every intuition you've ever trusted. That's not a poetic image. It's quantum physics, and it's real. Somewhere beneath the illusion of separation, beyond the comfortable fabric of space and the orderly march of time, lies a thread that sews the universe together in silence. It's not a bridge you can walk across, not a beam of light you can ride. It's stranger than both. It's a kind of relationship that survives any distance, resists isolation, and acts as if the very concept of here and there is missing the point entirely. Scientists call it quantum entanglement, a phenomenon so bizarre, so resistant to classical understanding, that even Einstein, who bent space and time to his will, threw up his hands and called it spooky action at a distance. Not because it was wrong, but because it worked. Repeatedly, precisely, and without any explanation that felt remotely sane. Entanglement isn't a theory anymore. It's an observation, a crack in the universe's mask, showing something deeper beneath. When two particles become entangled, they enter into a kind of contract, not written on paper, but written into the mathematics of their being. Measure one, and you instantly know something about the other. Not after a delay, not waiting for a signal, but in the same moment, even if they're separated by galaxies. The act of observing one becomes a kind of whisper across space, as if reality is less a map of places and more a web of intentions. This isn't some quantum parlor trick. It's repeatable, predictable, so consistent that it's being used to develop quantum computers and unbreakable cryptography. And yet no one fully understands how or why. Because if this is real, and it is, then the assumption that space separates must be wrong. The assumption that events are chained by time, by cause and effect, like dominoes in a line, must be incomplete. It suggests that reality isn't made of independent objects, but of relationships. Invisible threads that remain taut across impossible distances, vibrating in sympathy even when stretched to the edge of the cosmos. The implications are dizzying, because if entangled particles can coordinate across the void without sending signals, what else might be connected behind the scenes? We often think of ourselves as closed systems, minds sealed behind bone, alone in the cathedral of the skull. But what if that's just a trick of perception? What if your thoughts echo somewhere else? What if your emotions send ripples far beyond your body? What if consciousness itself is entangled? Not just metaphorically, but physically, resonating with people you love, even when they're not in the room, even when they're no longer alive. We don't know. We may never know. But the physics refuses to rule it out. And isn't it strange how that lines up with what you've always suspected? That some connections can't be explained by proximity, that some silences speak, that sometimes you just know, not because of logic, but because of something deeper, older, quieter. Entanglement undermines more than space. It threatens the concept of individuality. If two particles cease to be two, when entangled, if they become a single system, described only together, then what does that say about you and the people you've truly known? About the moments where you've merged with another, whether in love or grief or perfect mutual understanding? Perhaps those aren't just emotional metaphors. Perhaps they're glimpses of an underlying fabric we aren't trained to see. A kind of quantum intimacy, something primal and silent and real. You can try to pull away. You can cross oceans, burn bridges, erase names from your phone. But maybe, in some profound literal sense, once entangled, always entangled. You may forget, but the universe remembers. We like to imagine the universe as a grid, coordinates, vectors, light cones. But entanglement suggests that the real geometry of existence is stranger. Not linear, not local, more like a tapestry, folded and layered and woven so tightly that pulling one thread here moves another over there. And you are not above or outside of it. You are inside the fabric. You are part of the tension. And your choices, however small, matter. Because just as observation collapses the possibilities of a particle into a single outcome, your attention, your presence, collapses the potential futures of your life into reality. To look is to change. To care is to disturb the system. To act is to alter what might have been. You are not a spectator here. You are an entangled participant, bound into a cosmic equation with more variables than stars. And yet, in all this overwhelming strangeness, there is something oddly comforting. Because if you are connected, deeply, invisibly, to something beyond yourself, then maybe you're never truly alone. Maybe isolation is the illusion. And maybe, just maybe, every feeling of longing, every whisper of déjà vu, every sense that something or someone is with you even when they're gone, is not a failure of logic, but a quiet nod from the deeper rules. Rules that refuse to respect distance. Rules that do not forget connection. This changes how we see death too. In a universe where everything is local, loss is final. But in an entangled reality, something remains. Something lingers. Not in a spiritual sense, though perhaps that too, but in a physical one. The traces of interactions don't vanish. They become part of the structure. You carry every person you've loved in the field of your being, not in memory, in resonance. And perhaps the ache you feel isn't emptiness. Perhaps it's the stretch of the thread, tension across the quantum bond, the gentle pull of something or someone still echoing from far away. This isn't sentimental, it's physics. And physics, for all its equations and instruments, has stumbled into poetry. It tells us that the smallest parts of the world do not behave like isolated dots. They behave like dancers, choreographed by an unseen hand. When one bows, the other lifts. When one vanishes, the other sighs. When you observe, the system shudders. When you don't, it waits. And it is in this eerie, exquisite responsiveness that we find something terrifying and beautiful. The idea that reality is not fixed, not cold, not indifferent, but participatory, responsive, intimate. And that you, this flicker of thought, this moving center of attention, are part of how the world decides to become real. So the next time you stare into the night sky and feel small, remember, your smallness is entangled with the infinite. You are not an accident. You are a participant in the structure of meaning. You are a signal traveling through the web. And every breath you take, every observation you make, every word you speak into the silence matters, not just metaphorically, fundamentally, because reality is not out there waiting to be seen. It is here, in the act of seeing, in the bond that refuses to break, in the quiet miracle that you are not, and never were, alone. The Schrödinger's cat paradox. dead and alive until observed. Picture a sealed box sitting quietly on a table, motionless, ordinary, unremarkable. And yet inside it, something impossibly strange is happening. Something that seems to split the very idea of reality into two incompatible truths. There's a cat in the box, and until someone opens it, that cat is both dead and alive at the same time. Not metaphorically, not figuratively, but literally, if quantum mechanics is to be believed. The box becomes a coffin and a cradle, a paradox wrapped in fur and silence. And this scenario, born from a thought experiment meant to mock the absurdity of quantum theory, instead became its most haunting emblem. Because what it suggests is not just bizarre physics, it's a question aimed straight at the heart of existence. When does a possibility become a fact, and who or what decides? Erwin Schrödinger, frustrated with the implications of quantum superposition, invented the cat to make a point. But the universe didn't blink. Instead, it leaned into the idea. And the deeper we looked, the more it seemed the cat wasn't a joke, but a doorway. In quantum mechanics, particles do not have fixed properties until they are measured. An electron is not spinning clockwise or counterclockwise. It's both. A photon hasn't gone through slit A or slit B. It's gone through both. And the act of measurement, of observation, collapses that wave of probabilities into one reality. The universe, it seems, hesitates before making up its mind. And that hesitation, that liminal space between maybe and is, between potential and actual, is where the cat paces, unseen. The box isn't just a container, it's a theater, a stage where reality hasn't chosen its script yet. And you, the observer, are the director whose gaze decides the outcome. But this paradox is not confined to laboratory thought experiments or the poetic metaphysics of quantum theory. It spills into your life every day, whether you notice or not. Because you too carry boxes, silent moments in your memory, unresolved decisions, feelings you haven't dared to name. And until you open them, until you confront them, they remain like Schrödinger's cat, both true and false, both comforting and threatening. Every relationship you've left ambiguous, every ambition you've half pursued, every truth you've avoided, they are superpositions, possibilities not yet collapsed, realities waiting to be observed. You are not just living in the world, you are constantly collapsing your own wave functions, in what you choose to believe, to see, to acknowledge. The question becomes, how many cats have you locked away? And how many versions of yourself lie there, dead and alive at once? In this way, Schrödinger's paradox becomes something deeply psychological, because it's not just particles that remain undefined until observed. So do you. Your identity, your beliefs, your fears, all exist in a kind of flux until you turn your awareness toward them. You might think you are a confident person until you truly test your courage. You might believe yourself incapable of love until someone opens a door you never knew was there. Who you are is not fully determined until you dare to look. And like the cat, parts of you may both thrive and perish in the same breath until your consciousness chooses a path. The terrifying implication is that reality and selfhood itself is not something discovered, but selected. And yet, the hopeful implication is exactly the same. Nothing is final until it's observed, meaning you are not trapped. You are, at any moment, suspended in potential, waiting for the next observation to decide what happens next. And then there's the question of the observer. What qualifies as an observation? Is it the human eye, the act of knowing? Does the universe wait for you, specifically, to collapse it into form? Or is awareness more fundamental, an inherent part of the cosmos itself? Some interpretations suggest that consciousness plays a role in shaping what is real, that your very act of perceiving is creative, not passive. If this is true, then you are not just a visitor in this universe. You are a participant in its becoming. Every glance you cast, every conclusion you draw, every truth you refuse to see, all of it contributes to what exists. It means the boundary, between mind and matter may be thinner than we ever imagined. And that consciousness isn't riding the wave of reality, it's steering it. Of course, not everyone agrees. There are interpretations of quantum mechanics that try to sidestep this strangeness. The many worlds theory, for instance, proposes that all outcomes occur in branching, infinite realities, and what you observe is merely the version where your consciousness landed. In that case, Schrödinger's cat doesn't die or live. It does both, but in different universes. You are just one fork among many. It's a way of preserving objectivity, but at the cost of suggesting that the cosmos is constantly cloning itself into an incomprehensible tangle of timelines. And yet, even this interpretation cannot escape the central unease that what is real depends on where and how you look, that your perspective matters, not just emotionally, but physically, ontologically. So what do we make of this cat, this ghost of quantum indecision? Perhaps it was never about the feline at all. Perhaps it was always about us, about the way we live with ambiguity, the way we deny the unresolved, delay the inevitable, defer the decision. We are creatures of unopened boxes. We keep our potential both dead and alive. We avoid peering too closely at our choices, our truths, our contradictions, because we know that to observe them is to commit, and to commit is to kill possibility. But to never observe is to stay frozen. The box remains closed, and life, real life, never quite begins. And yet that box cannot remain shut forever. The longer you wait, the heavier it becomes. The more you delay the observation, the more you spread into shadow selves, ghosts of what could have been, wandering unchosen paths. Eventually, something forces your hand. The box opens, the truth arrives, and the wave collapses into a single, irreversible outcome. In that moment, you face the cost of having waited, or the relief of knowing, or the grief of what you've lost. But at least then, you are finally in the world again. Not hovering, but present. Not theoretical, but real. In this sense, Schrödinger's cat is more than a paradox. It is a mirror, a warning, a prayer. It invites you to consider how often you hesitate to know, to see, to decide. How often you live in the suspension, in the ambiguity, in the safety of not yet. It dares you to look inside your own boxes, not just the ones made of cardboard and memory, but the ones that hold your unlived life. And when you do, when you finally lift the lid, it doesn't matter what you find. Dead or alive, the cat becomes real. You become real. Because even grief is a more honest companion than uncertainty. Even loss is warmer than the cold of maybe. So open it. Open all of them. Step into your uncollapsed self. Speak the words you've left unsaid. Ask the questions you've avoided. Hold your contradictions in your hands and let them resolve. Because what you refuse to observe will continue to haunt you, not as fantasy, but as entropy, a fog that dulls your edges, a weight that slows your steps. And the cure is simple, though not easy. Look, observe, decide, live. The cat, the paradox, the possibility is waiting. The measurement problem. When does a possibility become real? There's a moment, impossibly brief, infinitely dense, that exists between what could happen and what does. A moment without form, without certainty, without direction. You can't touch it, or hold it, or even name it while it lasts. But everything you've ever done, everything you've ever become, has passed through it. It is the instant before the dice lands, before the lover speaks, before the universe makes up its mind. It is the edge of reality, the boundary between potential and presence. And in quantum mechanics, that moment has a name, the measurement problem. It's the question that haunts the heart of physics, like a riddle that laughs at its own answer. Because we know the equations. We know how a wave function spreads, how it describes a particle smeared across space, a ghost of possibilities. But the question that will not die is this: when does one of those possibilities become real? What causes the wave to collapse? What determines which version of reality we actually get? In classical physics, the world is simple. A ball follows a path. A clock ticks forward. Observation merely records what was already there. But in the quantum world, the script is reversed. Particles exist in superpositions. They are here and there, spin up and spin down, on this path and that one, all at once. Not confused, not uncertain, but genuinely multiple. Reality doesn't choose a version until something, or someone, measures it. And no one knows why. No one knows what measurement really is. Is it the interaction with a detector, the triggering of a sensor? Or is it deeper? Does consciousness itself play a role? Does the act of knowing collapse the unknown into being? That's the measurement problem, the uncomfortable, unavoidable realization that we do not understand how the universe picks one reality over another. That there is a crack in the logic, a missing verb in the sentence of existence. And in that crack, everything trembles. Because this is not just an issue for physicists in white coats, it's the story of your life. Every day, you live through wave functions of your own. You hold dozens of versions of yourself inside your decisions, the paths you could have taken, the people you could have loved, the words you could have spoken. And each time you act, you collapse a possibility. You select a future, you discard others. And the strange thing is, you never really feel the collapse. You only feel the aftermath. You feel the solid floor of what has happened, not the vibration of what almost did. But it's there, in the shadow of every choice, in the echo of every hesitation, in the ache of what never became. You live constantly on the edge of quantum becoming, collapsing probabilities into the thread of your personal timeline, one decision at a time. And so, the measurement problem becomes a metaphor for existence. What defines your reality? Is it what happens, or what you pay attention to? Perhaps reality isn't what occurs, but what is noticed, what is counted, what is held in awareness long enough to be remembered. If a tree falls in a forest and no one is there to hear it, does it make a sound? The old riddle now has quantum weight, because until it is measured, it may not have fallen at all. The universe seems to wait, in silence, in potential, impossibility, until attention renders it real. And if that's true, then the world is not a fixed stage. It's a canvas, an unfinished painting, a song that rewrites itself depending on who's listening. You are not watching the movie of your life. You are filming it, editing it, choosing which scenes to keep. Some interpretations of quantum theory try to sidestep this unsettling implication. They build elaborate frameworks to avoid the collapse altogether. In the many worlds interpretation, all possibilities happen, but in separate universes. In the de Broglie-Bohm theory, particles have definite paths guided by hidden waves. In objective collapse models, the wave function just collapses on its own after reaching a certain threshold. But none of these ideas have been proven, and none of them erase the question at the heart of the measurement problem. When does reality decide? And more hauntingly, who decides? Because deep down, there is a suspicion we cannot shake, that observation isn't just a passive mirror, it's a creative force. That something about consciousness, about awareness, bends probability into form. Not because the mind is magic, but because the fabric of the universe seems to respond to it. You see it in double-slit experiments, where particles behave differently depending on whether you try to observe their path. You see it in entanglement, where measurement on one side of the universe changes the outcome on the other. It's not that your mind changes matter like a wizard with a wand. It's that the act of noticing, of isolating one version of the world, rewrites the context, defines the borders, collapses the haze of maybe into the clarity of now. And that leads to an even more unsettling idea, that until something is measured, it does not exist in the way we understand. That the world is not out there, solid and waiting, but in, here, fluid and dependent on attention. That your entire reality may be a feedback loop between observation and expression, between awareness and emergence, between what you seek and what appears. You are not a traveler moving through a landscape. You are the artist, the frame, and the light. And every time you turn your gaze, the world becomes a little more real, a little more specific, a little more yours. But this power comes at a cost, because if what you observe becomes real, then what you ignore falls away. What you avoid collapses into absence. What you never dare to look at remains unformed, a pocket of unreality in the architecture of your life. And so, your measurement, your attention becomes a kind of ethical act, a responsibility. To observe is to honor existence. To witness is to participate in creation. To turn away is to erase. And suddenly, the quiet technical mystery of quantum collapse becomes a moral force. What you look at lives, what you refuse to see dies. And now, the measurement problem is no longer about electrons. It's about you, about the way you live, the way you choose, the way you hold the infinite in your hands and collapse it into something finite and call it reality. Every morning you wake up with 1,000 potential selves swirling in superposition, and every moment you spend, every breath you take, is a narrowing of that cloud into form, a crystallization of possibility into path. And that's terrifying, but also beautiful, because it means you are never truly stuck, never truly finished. As long as you are observing, as long as you are alive, you are still collapsing the future into being, still painting the canvas, still shaping the song. So, the next time you hesitate, remember, you are the observer. The world waits for you, not with impatience, but with possibility. The measurement problem doesn't ask you to solve it. It asks you to live it, to step into the uncertainty, to accept that reality is a verb, not a noun. That existence is something you do, moment by moment, gaze by gaze, breath by breath. You are not here to watch the universe. You are here to bring it into focus, to measure it into meaning, to collapse its chaos into clarity. One possibility at a time. The grandfather paradox. Can time travel break causality? Suppose you found yourself standing in front of a door that shouldn't exist. Tall, humming, impossibly cold to the touch. Behind it lies not a room, but a different year. A different decade. The past itself, breathing and waiting, like a theatre frozen mid-performance. And let's say you walk through. Let's say you go back, not minutes or hours, but generations. You find your grandfather as a young man, long before your parents were born, and in a moment of confusion or panic or fate, you do something irreversible. You end his story, which means yours never began, which means you were never born, which means you never went back, which means he lives, which means you return, and the cycle begins again. A loop with no anchor, no resolution, no logic that survives its own telling. This is not science fiction's playground. This is the grandfather paradox, and it is the tightest knot in time travel's thread, a riddle that mocks cause and effect and forces us to confront the terrifying fragility of what we call reality. At first glance, the paradox is simple. If you go back in time and alter the conditions that led to your existence, you erase your ability to go back at all. But the implications spiral outward like cracks in a frozen lake, because time, in every story we've ever told ourselves, flows in one direction, forward. Cause precedes effect. A dropped glass shatters, but no hand gathers the shards and reassembles it. But the grandfather paradox suggests that this flow might not be sacred, that the arrow of time, so central to our understanding of memory, identity, consequence, could loop back and pierce itself. And once you question causality, once you allow effects to influence their causes, the entire scaffolding of logic begins to sway. How do you define what's real in a loop that destroys its own origin? How do you draw a straight line when the paper folds? Some physicists try to sidestep the problem by invoking consistency, suggesting that the universe somehow protects itself, that any trip to the past would naturally prevent contradictions. You'd drop the gun, the bullet would miss, the timeline would heal around your interference like skin over a scar. This is called the Novikov self-consistency principle, and it's comforting. It tells us that the past is malleable only to the extent that it doesn't unravel the present. But comfort is not certainty, and other models offer less mercy. Multiverse theories argue that your interference would spawn a new branch of reality, one where your grandfather dies and you never exist, but also one where you didn't interfere at all, and you still do. Infinite timelines, infinite yous, a cosmic filing cabinet of alternate selves, each unaware of the others. And while that avoids paradox, it raises a different horror, that every version of you, the brave, the broken, the cruel, the kind, exists somewhere, playing out choices you never made but are somehow still responsible for. But let's step back. Let's ask a deeper question. Why does this paradox disturb us so much? Why does the idea of time folding in on itself, of you meeting yourself before you've arrived, feel so unnatural, so dangerous? Perhaps because we depend on causality the way lungs depend on air. It gives our lives structure. It allows stories to have beginnings, middles, and ends. It lets us believe that our actions matter, that choices have consequences, that the future is unwritten. If time can loop, if the future can rewrite the past, then what becomes of free will, of accountability, of selfhood? Are you the author of your life, or just a character trapped in a manuscript that's already been edited from the last page backward? And here's where the grandfather paradox transcends physics and becomes something human. Because don't we all, in some way, live inside it already? Haven't you wished you could go back, to say something you never said, to undo a hurt, to choose differently? Haven't you wondered how one conversation, one kiss, one road not taken might have rewritten the entire narrative of your life? That longing is the paradox, that ache to change the past, to twist the arrow of time and aim it in reverse, is not theoretical. It is the most intimate science fiction of the soul. And yet, even if time travel were possible, would it truly heal what haunts us, or would it fracture the very thread we're trying to mend? There's a cruel beauty to the paradox. It exposes the illusion that the past is stable, that the present is secure, that the future is merely waiting to be arrived at. It shows us that time is not a river but a maze, not a line but a knot. And in that knot, we're both the weaver and the thread. Every action we take tugs on strands we can't see, ripples through moments we haven't reached, and sometimes it feels like we're haunted not by ghosts of the past, but by versions of the present that no longer make sense if we look too closely. Like the future is already whispering back through the cracks. And yet, the paradox holds a strange hope as well, because if time is not fixed, if causality can bend, then maybe healing is not linear either. Maybe the consequences of pain don't have to stretch unbroken through every chapter. Maybe meaning isn't bound to chronology. You can't change what happened, but perhaps you can change what it becomes. The past may be written, but interpretation is a form of time travel. Memory is a kind of portal, and forgiveness of others, of yourself, is the act of choosing a different outcome within the same history. You can't erase the event, but you can collapse its meaning into something new, a lesson, a liberation, a softened edge where once there was only sharpness. So, the grandfather paradox remains unresolved, not because we lack the math, but because it forces us to confront questions that numbers alone can't answer. Questions like, is time a property of the universe or of consciousness? Is memory a record or a mirror? And if you could go back, truly go back, would you dare open the door? Would you save someone? Ruin something? Erase your own birth for the sake of a better world you'll never live in? Maybe that's the true paradox, not that time can be broken, but that we are already broken by time. That we are creatures who move forward while constantly looking backward, trying to rewrite with meaning what cannot be rewritten in fact. And in that tension, that impossible pull between regret and inevitability, we find not an answer, but a reason to live. Not to undo the past, but to honor it. Not to defeat the loop, but to step outside it. One choice at a time. Because, in the end, it may not matter whether time can fold. What matters is that you're here now. At the edge of becoming, holding the thread, writing the next sentence. The box of time is locked. The paradox remains. But you still get to decide what happens next. The Bootstrap paradox. Information with no origin. Imagine finding a book, not just any book, your book. A biography of your life, detailing everything you've ever done, everything you will do. You flip through the pages, stunned to discover events that haven't happened yet, conversations you haven't had, places you haven't seen, heartbreaks you haven't endured. It's all there, perfectly written. You read the ending, you memorize it. Years pass, and one day you write it all down, word for word, and publish it. And centuries later, someone else finds that same book, travels back, and hands it to your younger self. But here's the question: who wrote it? Where did the information originate? If the book exists only because it was passed along in a loop, with no true beginning, is it still real? This is the Bootstrap paradox, a knot in causality where effects become their own cause, and the origin of information disappears, not into mystery, but into perfect, impossible logic. At its heart, the paradox exposes the fragility of origin stories. We live by cause and effect. It's how we understand everything from falling apples to falling empires. This led to that, which caused this. But the Bootstrap paradox slices through that chain like a Mobius strip, a loop that turns back on itself, smooth and seamless, without a beginning or end. Named after the phrase, pulling yourself up by your bootstraps, doing the impossible. It's a time travel riddle in which something exists without ever being created. An object, an idea, a piece of music, a person's knowledge. It simply loops. Imagine receiving a blueprint for a time machine from your future self, building it, and eventually going back to hand it to your younger self. You've preserved the design. But who invented it? No one. It came from the loop. And yet, it's real. It functions. It exists. Physics doesn't deny this possibility outright. In fact, certain interpretations of general relativity allow for closed time-like curves, paths through space-time that loop back on themselves. These loops can, theoretically, allow particles or objects, or people, to return to their own past. And once loops are on the table, so is the paradox. Suddenly, information doesn't need an origin. It just needs persistence, like a whisper, in a cathedral that never fades, because each echo feeds the next. The loop sustains itself. But this raises a disturbing question. If something can exist without origin, without creation, then what else in your life, in your mind, might be part of such a loop? The paradox doesn't just haunt physicists. It tears at something deeper. Our need for grounding, for first causes. Humans crave beginnings. We ask, where did the universe come from? Where did life begin? What's the root of consciousness? The first note in the symphony? The first domino in the fall? The Bootstrap paradox laughs softly at these questions. It asks, what if the beginning is an illusion? What if some things loop, not as mistakes in the system, but as its most elegant feature? What if some truths are not born, but circulate? And this is where the paradox stops being about science fiction and becomes disturbingly personal. Think of inspiration, a melody that arrives in your mind fully formed, a sentence that writes itself, a dream that feels like a memory. Where did it come from? You say it came to you. But from where? Creativity, when traced backwards, often vanishes into mist. And perhaps some of those ideas, those insights, are bootstrapped, not invented, but received, not discovered, but recycled through minds across time. Your favorite quote, the one that guides your life. What if its first utterance was yours, in another time, given to a version of yourself that sent it forward? And then comes the existential weight. If something can exist without creation, can meaning exist without authorship? If a symphony loops through time forever, played by generations but composed by none, is it less beautiful or more divine? The bootstrap paradox breaks the pride of ownership. You didn't invent it, but you carried it, you preserved it, you honored the loop. And maybe, just maybe, that's the point. Not to claim creation, but to be a steward of continuity. It also forces us to rethink the nature of time. We like to imagine time as a straight line, from past to future, from cause to effect. But quantum mechanics, relativity, and paradoxes like this one hint that time may be far stranger. It may be flexible, looped, fragmented. Perhaps our need for linearity is just a survival instinct, a story we tell ourselves so we don't dissolve into the absurdity of all things happening at once. Because if time can loop, then stories can too. And you are both the reader and the author of your life, but not in the order you expect. And what does this mean for identity? If you are made of memories, and those memories are built on experiences, and those experiences were shaped by ideas, and those ideas came from nowhere, from loops, then who are you really? Are you a self-contained being? Or are you a node in a larger circuit, a carrier of patterns older than your birth? The bootstrap paradox turns identity into recursion. You are because you were. You were because you are. And the loop tightens. And deep down, maybe that's why this paradox unsettles us. It makes us question the integrity of our story. The idea that we are self-made, that our lives have clean beginnings and earned outcomes. The loop erases that comfort. It says, some things just are. No author, no start, no why. And yet this isn't nihilism. It's a deeper mystery, a reminder that not everything must be traced to matter, that some truths live outside the reach of origin. That perhaps the highest forms of beauty, of love, of wisdom, do not arise, but arrive. Circulate, return, like the seasons, like breath, like light caught in mirrors. And if we accept that, not as science fiction, but as psychological truth, then we begin to see life differently. We stop chasing firsts, we start listening for echoes. So the next time a thought finds you, a phrase, a vision, an idea, you cannot source, don't dismiss it, don't demand its birth certificate. Just hold it, let it loop through you, add your voice to its arc, pass it on. Because in a universe where origins fade, what matters is not who began the song, but who keeps singing. The black hole information paradox. Is information lost forever? Imagine burning a book, not just any book, the only copy of a story that defines someone's entire existence. You light the match, and within minutes, the pages curl, darken, vanish. The smoke drifts upward, the ashes fall, and the heat fades. But where did the story go? Not the paper, not the ink, the information, the details, the sentences, the truths, the choices, regrets, loves, secrets, and betrayals that lived between those covers. Are they gone forever? Or are they somehow still here, dispersed into the universe in a language we no longer understand? Now stretch this metaphor across the fabric of the cosmos, and you arrive at one of the most disturbing questions in modern physics. The black hole information paradox. It doesn't just ask where matter goes. It asks whether truth itself can die. Whether the universe, for all its laws and order, has a hidden furnace where knowledge disappears without a trace. To understand the paradox, we must begin at the edge, the event horizon. A boundary so absolute, so unforgiving, that even light cannot escape it. A point of no return. Cross it, and whatever you are, mass, energy, memory, complexity, is crushed beyond recognition. Inside, a black hole waits, a singularity, a region of infinite density and zero volume where the known laws of physics collapse. This is where Einstein's theory of general relativity reigns supreme, describing gravity so powerful it folds space-time like paper. According to this framework, when matter falls into a black hole, its properties are irretrievably lost, erased. But here's the problem. Quantum mechanics disagrees. Violently. Quantum theory, the backbone of our understanding of particles and fields, insists that information cannot be destroyed. It's sacred, immutable. Even if you scramble it, bury it, or stretch it across galaxies, it must persist in some form. Every particle that existed, every interaction it had, must be traceable. Because without this conservation, quantum mechanics breaks, predictability breaks. The very foundation of science, that identical causes produce identical effects, collapses. And yet, black holes seem to defy this. They swallow stars, planets, and yes, books, and emit nothing in return except Hawking radiation, a faint, featureless glow that carries no imprint of what was devoured. It's like the universe muttering a single meaningless syllable while hiding the body. This is the heart of the paradox. Two of our most trusted theories, general relativity and quantum mechanics, give us opposite answers. One says, information vanishes. The other says, that's impossible. But both can't be right, and yet both are right in every other context. So we're left with a contradiction that refuses to resolve. A cosmic tug-of-war between gravity and quantum logic, where the casualty is truth itself. Stephen Hawking was the first to truly spotlight this paradox in the 1970s. His groundbreaking work showed that black holes aren't perfectly black. They emit radiation due to quantum effects at the event horizon. Over time, they evaporate. They die. But the radiation they emit is random. It tells us nothing. Like ashes from the fire, it offers no clues about what burned. This leads to a horrifying possibility, that information, the very structure of reality, can be destroyed. That some things are not only gone, but made unknowable. That the universe, for all its beauty, has blind spots where meaning collapses into silence. But this idea was too horrifying for many physicists to accept. If black holes destroy information, they don't just delete particles, they shatter determinism. They break time symmetry. They ruin unitarity, the rule that quantum probabilities must always add up to 1. In essence, they make the universe a liar. So began a decades-long intellectual battle, not just to understand black holes, but to defend the integrity of reality itself. Some tried to save information by proposing that it escapes with the Hawking radiation, not as a clear message, but as a highly scrambled code, like burning a book and trying to reconstruct the story from the temperature and shape of each ember. It's theoretically possible, but mind-bendingly difficult. Others suggested that information clings to the event horizon, encoded on the surface, like a hologram, a concept that gave birth to the holographic principle, where our entire 3D reality could be a projection from a 2D surface. And then came the most radical proposals, that perhaps there are firewalls at the event horizon, bands of violent energy that destroy anything that touches them, violating the smooth fall predicted by relativity, or that black holes don't end in singularities, but tunnel through space-time into baby universes, realities disconnected from our own, where the information still exists, but will never be seen again. And in each of these theories, the universe becomes a stage for philosophical horror. Not monsters or ghosts, but truth without a witness, meaning that can never be verified, realities that remain forever hidden. but the implications go beyond physics. They reach into psychology, philosophy, memory, and identity. Because if information can truly be lost, then what does it mean to be remembered, to matter? If the details of a life, your thoughts, your actions, your impact, can fall into a black hole and vanish completely, does that life still have value? Or are we too at risk of becoming featureless radiation in time's long decay, known for our mass, but not for our meaning? And yet, there's another way to see it, a way that shifts the paradox from despair to mystery. What if black holes don't erase information, but transform it? What if the universe is not a vault, but a crucible, melting down complexity into something new? After all, stars are born in the ruins of other stars. Maybe meaning isn't destroyed in the black hole. Maybe it's rewritten. Maybe memory is not lost, but translated into a language we don't yet speak. And maybe you, right now, are the proof. Because if information must be preserved, then everything you've seen, thought, loved, or feared is still out there. Encoded in the fabric of the cosmos. Reflected in the way particles interact, whispered in the radiation of the stars. You are not a temporary arrangement of matter. You are an ongoing imprint on the deepest level of existence, a ripple that never stops echoing. So the black hole information paradox remains unsolved, and perhaps that's appropriate, because it doesn't just test equations, it tests faith in reality. It forces us to confront a universe that may not owe us answers, but still compels us to ask. And in that tension, between what's known and what's lost, we find something truly human. The need to remember, the refusal to let go, the belief that nothing meaningful can ever fully disappear. Maybe that's why we tell stories, why we write, record, and recall. Because deep down, we're trying to outrun our own event horizon, to prove that information, that truth, doesn't die with us, that even in the darkness, something survives. And maybe, just maybe, the paradox isn't about what black holes do. It's about what we do in the face of the unknown, whether we burn the book or write it again in every star we become. The Fermi paradox. Why haven't we found aliens? Imagine standing on a beach at night, the tide gentle, the sky infinite. You look up and see a black canvas speckled with starlight, each point a sun, many with planets, some perhaps just like Earth. Now imagine shouting into that vast sky, not with your voice, but with everything we've ever transmitted. Radio waves, spacecraft, whispers of curiosity. And then imagine waiting. Decades pass, centuries. You receive nothing in return. No echo, no reply, no flicker of acknowledgement. The stars remain silent. The silence grows louder, and one question pulses louder than all others. Where is everybody? This is the Fermi paradox, the contradiction between the high probability of extraterrestrial life in the universe and the stark, unyielding absence of evidence for it. It is not just a question about aliens. It's a question about us, our place, our future, our hope. The math is almost cruel in its optimism. The Milky Way alone contains over 100 billion stars. If even a fraction of them have Earth-like planets, and if even a fraction of those developed life, and if even a fraction of those evolved intelligence and technology, then the galaxy should be teeming with civilizations. Even if only 1 in a million planets births a species that reaches the stars, we should see signs, signals, artifacts, beacons, ruins. We should see something. And yet, we don't. Our telescopes sweep the heavens. Our probes wander the void. Our radio dishes stay tuned. But the universe remains cold and indifferent. A theater with no actors, no applause, just empty seats and flickering lights. This silence isn't just strange, it's haunting. Because silence is data. Silence is an answer. The paradox is named after physicist Enrico Fermi, who casually, posed the question during lunch in 1950. If the universe is so vast and old, and life should be common, then why haven't we been visited? His question was simple, but its implications are devastating, because it forces us to confront the possibility that we are either incredibly special or deeply alone. So where are they? The answers proposed range from sobering to terrifying. Some suggest the rare Earth hypothesis, that while life may be common, intelligent life is not. Maybe it takes a freak cocktail of ingredients, magnetic fields, plate tectonics, a stable sun, a large moon, to protect and evolve consciousness. Maybe Earth is not just rare, it's singular. Others propose the Great Filter, an invisible wall in the timeline of civilization that most never pass. Maybe life arises easily, but it hits a ceiling. War, climate collapse, AI run amok, biological self-destruction. Maybe we haven't heard from others because they didn't make it. And maybe we haven't heard from our future selves either, because we won't make it. The silence becomes not absence, but warning. And then there are darker theories. That civilizations go silent on purpose. That any species wise enough to build interstellar technology also knows the danger of being seen. That in a universe where predators may roam, the first rule of survival is silence. Broadcast nothing, hide, encrypt. The cosmos becomes a galactic jungle of paranoid species, each cloaked, each listening, none daring to speak. And in this vision, Earth, noisy, curious, naive, glows like a target. Still others say the aliens are here, but we can't perceive them. Maybe they're post-biological, not flesh and bone, but swarms of self-replicating nanobots, or patterns in dark matter, or AI intelligences existing in quantum substrates. We look for antennas, for rockets, for cities, but they've moved on. They've evolved beyond our imagination. Or maybe they are watching us like we watch ants, fascinated but distant. Maybe we're inside a cosmic zoo, quarantined until we grow up. Or perhaps, and this stings most of all, we're just early. Maybe intelligence is rare, but we are among the first. The stars haven't answered because no one's asking yet. The silence isn't rejection, it's anticipation. And maybe our role is not to listen, but to speak first. But now step back. Because the Fermi paradox is not just about aliens, it's about introspection. It forces us to ask, what kind of species are we? What future are we heading toward? Because every answer to the paradox is a mirror. If civilizations destroy themselves, what does that say about our path? If they go quiet, what does that say about the dangers of communication? If they hide, what do they fear? If we are alone, what responsibilities do we carry? And yet the paradox also inspires wonder. It whispers that maybe the most advanced civilizations are the quietest because they've learned not just to survive, but to harmonize, to exist without conquest, expansion, or ego, to create meaning inwardly, not endlessly seek it outward. Maybe intelligence doesn't manifest as noise, but as stillness. Maybe the absence of a galactic empire is not failure, it's wisdom. And maybe, just maybe, the universe is not silent because it's empty, but because it's at peace. Still, the silence haunts us. We build telescopes and send probes not just for science, but for company. For confirmation that we are not a fluke, that our hopes and fears, our struggles and joys, our art and wars and dreams are not the only story being written. We search the stars because we want to belong to something greater, to know we are part of a cosmic choir, even if we sing alone for now. And here's the final irony. In asking, where is everybody, we reveal the depth of our loneliness, but also our hope. Because only a species capable of imagining others is capable of imagining more meaning, more connection, more purpose. And maybe that hope is the real answer. Maybe we haven't found aliens yet because we're meant to become them. To rise above our noise, to learn, to endure, and someday to send out not just signals, but stories. So next time you look at the stars, Don't just ask who's out there. Ask who we're becoming. Because if the universe is listening, and if the silence is not an absence, but an invitation, then maybe the most important message is the one we choose to send next. The Gibbs paradox, mixing identical particles, changes entropy. Imagine two rooms, side by side, each sealed tight, each filled with a gas, same temperature, same pressure, same number of molecules. The twist: the gases are identical, hydrogen, in both say. You open a valve between the rooms. The gases flow, mix, balance, and then you close it. What changed? You might say, nothing. Same contents, same state. But according to classical thermodynamics, something did change. Entropy increased. The system is now more disordered. But how? If everything was already the same, what exactly mixed? This is the Gibbs paradox, a quiet rebellion against the obvious, a whispered challenge to how we understand identity, difference, and the very nature of information. It's a paradox not because it breaks the rules, but because it exposes the limitations of the rules themselves. And it forces us to ask, can something become more chaotic, even when nothing truly changes? At first glance, the Gibbs paradox seems like a bookkeeping error, an artifact of math, but beneath that lies a deeper wound. A contradiction between classical and quantum understandings of individuality. In classical physics, every molecule, no matter how similar, is still distinct. Like billiard balls, they can be numbered, tracked, labeled. So when gas A flows into gas B, even if both are made of hydrogen, each particle is still from one side or the other. This movement is mixing, and mixing, according to thermodynamics, increases entropy, a measure of disorder, of unpredictability. But the contradiction arises when the gases are identical in every way, not just similar, but truly indistinguishable. In the quantum realm, particles like electrons or hydrogen atoms don't carry labels. You can't say, this one came from the left room. They are not individual actors, but waves overlapping in a field. The concept of identity itself begins to blur. This is where the paradox blooms. If you mix two different gases, say hydrogen and helium, the increase in entropy makes intuitive sense. The molecules are distinguishable. There's more complexity, more uncertainty. But when mixing two identical gases, does entropy still increase? Classically, yes. But quantum mechanics says no. If particles are truly indistinguishable, there's no new information, no increase in possible arrangements. And entropy, at its core, is about information, about how many ways a system can be rearranged without changing what you observe. So, which is it? Does mixing identical particles create disorder, or reveal that disorder was an illusion? This paradox is not just academic. It strikes at how we define reality. If identity requires distinguishability, then indistinguishable particles have no identity. And if identity vanishes at the quantum level, what does that say about the structures we build atop those particles? Atoms, molecules, matter, us. The Gibbs paradox reveals that even the fundamental concept of individuality is conditional, statistical, emergent. The world you see as made of things may, at a deeper level, be made of possibilities, not pieces. And now the metaphor sharpens. Picture a crowd of people in a room, all dressed identically, all acting the same. You open a door to an identical room with an identical crowd. They flow, they mingle. But from a distance, nothing has changed. No new combinations, no surprises. Yet the system has changed. There's more unpredictability, more pathways. Or is there? What if you couldn't tell the difference between any two people? Would you still call it mixing? Or is it an illusion of change? The paradox also haunts our understanding of entropy. Traditionally, entropy is seen as a measure of disorder. But that's not quite right. Entropy is about possibility. The number of microstates that correspond to a macrostate. If you have no way of telling one gas particle from another, then switching them doesn't create a new configuration. The number of possible microstates is lower than you thought. and entropy, being tied to that number, decreases accordingly. The paradox, then, is a challenge to our assumptions about what counts as information. It reminds us that even disorder requires context. To see chaos, you must first believe in identity, but it gets stranger. The resolution of the paradox comes not from physics alone, but from philosophy. Quantum statistics, Bose-Einstein for bosons, Fermi-Dirac for fermions, forces us to redefine individuality. In quantum mechanics, some particles prefer to be indistinguishable. Electrons must be different. Photons love being the same. And in this framework, the paradox dissolves. Not because we solved it, but because we transcended the assumptions that made it seem paradoxical in the first place. It's not that entropy increases when identical particles mix. It's that we thought they were individual in the first place. The mistake was in our perception. And now, step further into metaphor. What if you applied the Gibbs paradox not to gas, but to thoughts, to people, to cultures? What happens when two seemingly identical ideas interact? When two individuals raised in parallel environments meet? Does anything change? Is there real mixing? Or is it only when differences are perceived that transformation occurs? The paradox becomes a lens to examine identity, difference, and sameness in the human experience. It challenges the notion that change always requires contrast, that growth requires otherness. Maybe, like particles, we too are distinguishable only by context. And when context fades, we melt into the field. But this doesn't mean we are meaningless copies. It means that identity may be relational, not intrinsic. You are who you are because of your position in the whole. Not as an isolated atom, but as a pattern, a probability, a resonance in the field of existence. The Gibbs paradox teaches humility, that our need to label, to name, to count, while useful, is not ultimate truth. That even in a room full of identical possibilities, something profound can emerge when you change the way you look at what never changed. In the end, the paradox invites a kind of surrender, to accept that entropy, identity, and order are not fixed things, but shifting shadows on the wall of a deeper physics. That maybe the gas never mixed, but your understanding of what it means to mix did. And that shift in understanding, quiet, invisible, is perhaps the real entropy, the real change, the real paradox. So next time you open a door and nothing seems to change, ask again, what just happened? Because in physics, as in life, sometimes the greatest transformations are the ones we can't name but only feel, the arrow of time. Why time moves forward. When physics says it doesn't, you never wake up before you fall asleep. A broken glass never leaps back onto the table and reassembles itself. You remember yesterday, not tomorrow. These are not just curiosities. They are laws etched deep into your perception of existence. Every heartbeat, every sunrise, every breath you've ever taken flows in one direction, forward. We call this the arrow of time. It's so intuitive, so unquestioned, that we treat it as fundamental. And yet, when we look into the mathematics that govern the universe, Newtonian mechanics, quantum equations, even Einstein's fabric of space-time, nowhere does it say time must move in one direction. In fact, the equations of physics work just as well in reverse. The universe could run backward and still obey all the same rules. So why doesn't it? Why do we experience a relentless forward motion through time, when the very laws that govern reality remain indifferent to direction? This is the arrow of time paradox, a quiet but seismic contradiction between human experience and universal logic. And at its heart lies a deeper question. Is time's forward flow a truth of the cosmos, or merely an illusion born from entropy, memory, and the fragile psychology of order? To begin unraveling this thread, imagine time not as a flowing river, but as a frozen block, a loaf of bread where each slice is a moment. Past, present, and future all exist simultaneously, stacked side by side. In the world of relativity, this model, the block universe, replaces the idea of a moving now. Nothing actually flows, instead everything is. Motion, in this view, is not real. It's perception, sliding through a fixed dimension. But our lived experience rebels against this notion. We feel time. We measure it. We mourn it. We fear its passing. And we age. Oh, how we age. Wrinkles don't smooth themselves. Ashes don't turn back into flames. Ice melts, but puddles don't refreeze spontaneously. There is a direction to things, and that direction is inextricably tied to entropy. Entropy. The measure of disorder in a system may be the only quantity in physics that demands time to move forward. Every natural process, from the diffusion of perfume in a room to the decay of radioactive atoms, follows the second law of thermodynamics. Entropy must increase. Systems evolve from order to disorder, not the other way around. It is this law, not some mystical arrow, that gives time its perceived direction. But entropy doesn't explain why the universe started in a low entropy state to begin with. And that's the real mystery. Why was the early universe so improbably ordered? Why did everything start so tidy, so wound up, so ready to unravel? It's like finding a sandcastle in the middle of a desert storm. Not just fragile, but utterly unlikely. Here, the paradox deepens. Because if entropy is the only thing enforcing time's flow, and if the laws of physics are otherwise time-symmetric, then time's arrow is not fundamental, it is emergent. It arises from boundary conditions, the initial state of the universe. We remember the past because it was ordered. We anticipate the future because it will be less so. Memory, in this light, is not proof of time's flow. It is a psychological consequence of entropy's increase. Our entire sense of causality, of before and after, may be nothing more than a narrative our minds create to survive in a universe where particles don't care about story. Now picture a shattered mirror. Its edges reflect 1,000 fragments of what once was whole. That's your memory of time. We gather pieces, form a picture, and call it the past. But the future? It hasn't been constructed yet. Not because it doesn't exist, but because we lack the entropy gradients to predict it. Our biology, our logic, our language, all biased toward a forward march. Even our emotions betray this bias. Regret clings to what's behind us. Hope reaches toward what's ahead. But if the universe truly plays fair with time, if the equations permit both directions, then perhaps there are beings, or perspectives, that remember tomorrow, that grieve what has yet to happen, that regret decisions yet unmade. This paradox doesn't just challenge physics, it tears at the roots of free will, determinism, and identity. If the future already exists in the block universe, are we merely reading a script? Is the present just our consciousness sliding across a page, already written? Or are we, through choice and awareness, shaping entropy's path as we go, burning bridges behind us that cannot be rebuilt? Some physicists suggest that time itself might not be real at all, merely an emergent phenomenon from quantum entanglement, decoherence, or even observer consciousness. If so, what we perceive as flowing is not time, but change, the shifting relations between states of being. In this light, time is not a river, but a kaleidoscope, always complete, ever rearranging. The implications ripple through every field of thought. In philosophy, the arrow of time raises questions about meaning. If time is a construct, does purpose exist beyond entropy? In psychology, it probes trauma and healing. Why do memories of pain persist, but visions of joy feel fleeting? In art, it inspires non-linear narratives, loops, reversals, attempts to escape time's tyranny. And in cosmology, it points toward the end, the heat death of the universe, where entropy reaches its peak, and all gradients, all difference, vanish. No motion, no thought, no contrast. Just an eternal stillness. A universe that remembers nothing, anticipates nothing, and becomes, in the most literal sense, timeless. But maybe this is where hope enters. If entropy defines the arrow of time, then life, fragile, temporary, improbable life, is a rebellion against it. Every act of creation, every moment of love, every spark of meaning carved from chaos is a small reversal, a local bubble of order rising against the tide. Life does not deny entropy. It dances with it, building temporary structures of beauty before returning to the sea. In this sense, the arrow of time is not a prison. It's a canvas, and the brevity of the stroke is what gives it power. So, next time you feel time slipping through your fingers, remember this. What you're experiencing is not the universe moving, it's you. You, as a conscious observer, painting forward into the void with every thought, every choice, every breath. The arrow of time may be born from chaos, but it's guided by perception. And in that fleeting space between past and future, we don't just exist, we become. The EPR paradox. How can particles coordinate faster than light? What if every decision you made, every secret you whispered, every heartbeat you felt was instantly echoed by something, somewhere, unimaginably far away? Not metaphorically, not emotionally, but physically, truly, in the bones of the universe itself. Imagine flipping a coin in Paris and, in that same instant, a matching coin lands in Tokyo, always aligned, always opposite, with no signal exchanged. That's not science fiction. That's the riddle Einstein tried to silence, and the phenomenon he feared might reveal cracks in the very foundation of reality. The EPR paradox, named after Einstein, Podolsky, and Rosen, isn't just a footnote. In quantum physics, it's a doorway to something that feels suspiciously like magic, a defiance of distance, a challenge to causality, a whispered suggestion that the universe might be woven together by threads so invisible, so instantaneous, that even light can't keep up. To understand this puzzle, step into Einstein's mind in 1935, a place both precise and rebellious. He and his colleagues sought to expose what they saw as the incompleteness of quantum mechanics. According to their logic, no theory should permit a measurement in one place to instantly affect another point in space without something, a signal, a cause, a medium, traveling between them. They called this spooky action at a distance, not to celebrate it, but to mock it. It offended Einstein's belief in local realism, the idea that physical effects must have local causes, and that reality exists whether you observe it or not. But quantum entanglement, the very core of this paradox, laughs at such beliefs. Picture two particles born together in the same quantum cradle. Let's say they're electrons with opposite spins. Once entangled, their fates are forever tied. Measure one, and the other instantly knows how to respond, no matter how far apart they are. One turns left, the other turns right. Not with delay, not with hesitation. Instantly, even if they're light years away. You could separate them across galaxies, bury them behind stars, and yet their responses remain synchronized like ghostly dancers. No signal is sent, no energy exchanged, no path traced between them. And that's the scandal. Not that they influence each other, but that they seem to do it outside of time, beyond space. Quantum physicists, armed with Bell's theorem in the 1960s, later proved that no hidden variable, no secret instruction or pre-coded message can explain this behavior. The universe, it turns out, doesn't play by classical rules. Experiments from the 1980s to today confirmed it again and again. Particles entangled truly act as one system, no matter the distance. The act of observation doesn't just reveal a reality, it creates one, collapsing a field of probabilities into a specific outcome. And in doing so, it redefines its twin, instantly. But if no message can travel faster than light, how does this coordination happen? What thread connects the outcomes? Here, the walls begin to melt. Some theorists suggest that space and time, as we perceive them, are not fundamental. That at the deepest level of the universe, location and sequence may be illusions, emergent phenomena created by deeper quantum relationships. Others lean toward non-locality, the idea that entangled particles are not truly separated, but remain part of a singular, undivided system regardless of distance. In this view, the cosmos is not a grid but a web, and every part of it hums with the tension of all the others. To ask how the particles coordinate is like asking how the two ends of a seesaw communicate when one goes down. They don't talk. They're part of the same structure. But beyond physics, the EPR paradox whispers something more unsettling, that separation itself might be a lie. If particles can be connected across the void, might minds be too? Are we islands, or are we waves on the same ocean, appearing apart only because we see the peaks and not the undercurrent? In Entanglement, we glimpse a reality where information doesn't travel. It is. A place where knowing is instantaneous, not because it was sent, but because it was never apart. And if the universe is stitched from such fabric, then what does that mean for memory, for empathy, for the bonds we feel without explanation? Entanglement doesn't stop at particles. Entire systems, atoms, molecules, even small biological structures can be entangled. Theoretically, large objects could be too, if not for decoherence, the process by which interaction with the environment disrupts entanglement. But if somehow a conscious being could maintain quantum coherence, what would they feel? Would they know the thoughts of another across the stars? Would they see themselves as part of a singular mind, dispersed but undivided? The implications are as dizzying as they are poetic. Love, intuition, déjà vu. Could these be echoes of entanglement, misunderstood by a species that mistrusts the unseen? Einstein died believing quantum mechanics was incomplete, that someday a deeper theory would restore logic and locality. But each decade has only deepened the mystery. The more we test it, the more we find the universe is not a machine ticking forward in predictable gears, but a web of uncertainty, where observation weaves reality and connection supersedes distance. In this landscape, knowledge is not passed. Like a letter, but revealed like a light switch flipped on both sides of space at once. And you, the observer, are not outside the experiment. You are entangled within it. So next time you feel alone, consider this. On some impossible quantum level, you might still be touching someone you've lost, still exchanging silent messages with a version of yourself in another place, another moment, another possibility. The EPR paradox doesn't just show us that the universe is connected. It insists that we are too, not by signals, not by wires, but by something stranger, a reality that doesn't wait to travel because it was never divided to begin with. The ultraviolet catastrophe. Where did the infinite energy go? Imagine you walk into a room flooded with sunlight, pure, warm, vibrant. You close your eyes, and for a moment, you don't see the light. You feel it. It touches your skin, warms your blood, floods your brain with a sense of order and safety, as if the universe outside the window knows what it's doing. But what if I told you that this everyday miracle, the light of a candle, the heat of a stove, the glow of a sunrise, nearly shattered the very foundation of classical physics? That at the turn of the 20th century, the greatest minds on Earth stared into the heart of thermal radiation and discovered something terrifying. A crack in the logic of reality so deep, it predicted that every object in the universe should emit an infinite amount of energy, instantly incinerating itself and everything around it in a burst of ultraviolet death. No explosions, no fire, just a silent, invisible catastrophe baked into the math. This wasn't a science fiction story, it was the logical conclusion of everything physicists believed at the time. A crack so strange it earned a name, the ultraviolet catastrophe. And from that abyss of theoretical doom, modern physics was born. To understand this paradox, you must first step into the minds of 19th century scientists trying to understand blackbody radiation. A blackbody is not sinister. It's simply a perfect absorber and emitter of radiation. an idealized object that neither reflects nor transmits energy. Picture a hollow metal cavity heated from the inside, glowing brighter as it warms. Classical physics, armed with the Rayleigh-Jeans law, tried to predict the intensity of this emitted light across different wavelengths. At low frequencies, the predictions matched observations beautifully. But as the frequency increased into the blue, violet, and ultraviolet ranges, the math spiraled out of control. According to classical theory, the energy output should grow without limit. The hotter something became, the more short wavelength radiation it would emit, and since shorter wavelengths could be packed infinitely into a spectrum, the total emitted energy would be infinite. Let that sink in. Infinite. From a single object, from a candle flame, from your skin, from the very atoms in your body. That's not just absurd, it's physically impossible, and yet the equations demanded it. It was as if reality itself had slipped a note under the door saying, "Your understanding is broken." This wasn't a minor miscalculation. It was a devastating indictment of everything Newtonian physics stood for. The ultraviolet catastrophe called into question the very nature of light, heat, and matter. If taken seriously, it meant that the more you tried to describe nature using classical tools, the more it spiraled into madness. The universe, which had appeared clockwork and deterministic, was now hiding an infinite fire beneath its surface. It was like discovering that the foundation of your home is made of paper, and you only realized it when it caught fire. And then came a man whose quiet equations would whisper an entirely new language into the ears of physics. Max Planck. Planck didn't set out to revolutionize science. He was, by all accounts, a conservative thinker, hoping to patch the hole in classical physics, not rebuild the building. But as he tried to solve the radiation problem, he made a radical assumption: that energy is not emitted continuously, but in discrete packets, quanta. This was not an aesthetic choice, it was desperation. If energy could only be exchanged in tiny chunks proportional to frequency, then the infinite climb of ultraviolet radiation could be stopped. The math worked. The catastrophe vanished. But what Planck didn't know, what he perhaps feared, is that this assumption cracked open the door to a completely new universe, a place where particles act like waves, where energy comes in indivisible packets, and where observation rewrites the script of what's real. Planck had not saved classical physics. He had buried it. And from its grave, quantum mechanics began to rise. But the paradox doesn't die with Planck's solution. It haunts us still. Because in making peace with experimental data, we invited chaos into the core of reality. Energy, once a smooth river, now flowed in pulses. Light, once thought to be a wave, now came with particle-like behavior. And more disturbingly, the boundary between what is and what could be blurred. Quantum theory told us that the very fabric of the universe is probabilistic, not deterministic. That uncertainty isn't just a measurement error, it's built into the code of reality. All because the classical world couldn't survive its own predictions about light. And here, the metaphor deepens. The ultraviolet catastrophe isn't just a physics mistake. It's a reminder that our logic, our certainty, our grand theories can crumble not from what we don't know, but from what we thought we did. Let's imagine for a moment that your thoughts were light, that your mind emits ideas like a black body emits radiation, some long and slow, others sharp and quick. Now imagine you try to apply classical logic to your own thinking, to predict your future choices, emotions, dreams, using only cause and effect. You'd run into your own version of the ultraviolet catastrophe, the belief that you are infinitely knowable, that every emotion has a cause, every decision a formula. But just as reality defied the physicists of the 1800s, so too does the human mind defy clean equations. Perhaps we too are quantized, irrational, unpredictable, flickering between possibilities. And maybe that's not a flaw. Maybe it's the signature of something deeper. In the end, the ultraviolet catastrophe wasn't a catastrophe at all. It was an awakening. a cosmic fire drill that revealed the limits of our old beliefs and forced us to listen to the quiet, chaotic whisper of the quantum world. It's a reminder that the most beautiful truths are often born in the wreckage of certainty, that when the math screams impossibility, we should lean in, not run away. Because in that moment, between what we expect and what is, we find the threshold of true discovery. And perhaps like Planck, like the universe itself, we must sometimes shatter our logic to glimpse a deeper order hidden in the noise. The twin paradox, time dilation, and the aging problem. They were born within seconds of each other, the world barely blinking between the first breath of one and the cry of the next. Two lives launched in perfect symmetry, mirror images wrapped in the same blanket of time, sharing lullabies, scraped knees, and synchronized bedtimes under the indifferent ticking of a bedroom clock. But from the moment one of them stepped into a vessel designed to flirt with the speed of light, that sacred symmetry was shattered, not with a bang or a cry, but with the quiet, invisible distortion of time itself. This is no fairy tale. It's a physical, measurable, unsettling truth. According to Einstein's special theory of relativity, time is not the universal heartbeat we once believed it to be. It is pliable, warped by velocity and gravity, different for each observer depending on their motion. And in the case of these twins, the one who rocketed across the galaxy and back returned with only a few months added to their age, while the one who remained rooted to Earth had lived through years. This isn't fiction. It's been proven. Atomic clocks flown around the Earth tick differently than their stationary counterparts. But the twin paradox is more than a curiosity for physicists. It's a philosophical guillotine cutting cleanly through our concept of time, aging, identity, and reality itself. What does it mean to be a sibling, a twin, if time itself no longer treats you equally? The paradox begins not in the equations, but in the mirror, when the one who left returns home and finds a face aged with stories they weren't there to witness. Weddings, funerals, revolutions, heartbreaks, recoveries, all passed in the blink of a cosmic eye for the traveler, but unfolded fully for the one who stayed. This split in time is not metaphorical. It's empirical. The same laws that govern light and mass determine that high-speed motion slows your experience of time. Imagine reading a book while the world around you races through seasons. By the time you finish a chapter, entire lifetimes have passed. The twin in the spaceship lives in that book, cocooned from entropy, preserved by speed. But the cost is heavy. Time isn't just what a clock measures. It's the texture of living, the sibling, who stayed aged not just in skin and bone, but in wisdom, in scars, in dreams reshaped by reality. They waited, they changed, they moved on, and now the twins face each other across a temporal abyss, unable to reconcile two timelines split by motion, but joined by blood. But the twin paradox also stretches the limits of what we believe about cause and effect, about simultaneity, about free will. If time can pass differently for two people depending on how fast they move, then what does now even mean? For the traveler, now is suspended, thinned out like light across a vacuum. For the one who stayed, now has been stuffed with memories, regrets, decisions, and yet both believe they are living in the present. Which is real? If two people experience time at different rates, then they live in different worlds, intersecting, only occasionally, like cosmic orbits briefly aligning before drifting again. This isn't just physics, it's a portrait of modern life. We all live in fragmented time. One person races through ambition, deadlines, and noise, while another moves slowly, rooted in moments, shaped by stillness. We say we're living together, but are we? The twin paradox exposes a silent truth. Synchronization is an illusion. We age at different speeds, not just through physics, but through attention, trauma, hope. Your childhood friend may be your twin in age, but life may have aged them decades ahead or behind you. We think of time as a shared canvas, but perhaps it's a set of private mirrors, each curved by our individual momentum. And what about memory? The twin who traveled returns to a world they barely recognize. Their mind contains a continuous thread, takeoff, a few dreams, return. But the other twin's memory is a collage of absence. Birthdays alone, letters unanswered, a shadow seat at every dinner. How do you share a past when your durations don't match? Memory, like time, bends, and when it bends too far, it snaps. The emotional trauma of the twin paradox lies not in science, but in this rupture. How do you reconnect with someone who left young and returned young while you grew old waiting? Can love stretch across time dilation? Can relationships survive relativistic exile? Or does time itself erode bonds the way it wears down mountains? We long for constancy in others, but the universe gives us only motion, decay, and asymmetry. The twin paradox is a metaphor for every reunion after long absence, for soldiers returning home, for lovers meeting after years apart, for siblings estranged by distance or belief. You hope nothing changed, but everything did. Even more disturbing is the implication that there is no absolute measure of time at all. No master clock ticks somewhere behind the universe. Time is not a backdrop. It's woven into the observer. In fact, the traveler's slowing of time is not a trick. It's a legitimate lived experience. They didn't skip anything. The time they experienced is the only time that existed for them. This makes every attempt to compare timelines somewhat meaningless. There is no standard against which to measure who lived more. Both lived, fully, just differently. And so, the twin paradox becomes a moral and existential riddle. If time is relative, then so is life. Then so is value. Then so is truth. You cannot judge another's journey by your clock. You cannot define their growth by your calendar. Each of us moves through a private corridor of time, affected by choices, by speed, by gravity, by emotion. The paradox is not simply about physics. It's a cry against comparison, a plea for empathy, a call to recognize the impossibility of truly knowing what it was like for someone else. In the silence between these twins lies the most profound echo of all, the realization that time itself does not flow. It does not move like a river. It is not passing in any universal sense. Rather, all moments already exist, laid out like pages in a book we are forced to read one line at a time. The twin who traveled didn't delay time. They just read a shorter chapter. The one who stayed read more. And perhaps that's the most haunting lesson. Not that one lived less, but that life is not in the quantity of pages, but in the meaning drawn. From each line, you can race ahead and skip ahead, but you may miss what makes a moment matter. Or you can walk slowly, feel every sentence, and still be left behind. Either way, you are caught in a paradox, choosing between motion and meaning, between longevity and connection, between preservation and presence. And so the paradox lingers, not just in labs or theories, but in everyday decisions. In our rush to achieve, to go faster, to reach the stars, are we leaving behind those who matter? Are we aging out of relationships, out of ourselves? And if we could return, physically unchanged, would the world still have a place for us? Would the people we love still remember how to speak our language, still see our face behind the years? The twin paradox is a wound dressed as an equation. It is the sorrow of time's asymmetry. It is the knowledge that no matter how synchronized we begin, we will all drift apart, carried by forces beyond our control. Motion, ambition, gravity, grief. And while science explains the mechanism, it cannot touch the ache of arriving home and not recognizing the hands that once held yours, the ache of being young in a world that grew old without you, the ache of timelines that cannot be reconciled. So perhaps, in the end, the lesson is not how to defy time, but how to accept its distortions, to love even when clocks betray you, to listen even when memories don't match, to recognize that every reunion is a negotiation between parallel lives, and to remember, always, that what makes time precious is not its duration, but its presence. Because whether you are the twin who stayed or the one who left, the universe offers no guarantees of alignment, only brief intersections, only fleeting overlaps, only the hope that, when your paths do cross again, you'll still remember how to find each other across the widening gulf of experience. Zeno's paradoxes, infinite halves and motion that never starts. Imagine standing at the edge of a finish line, watching someone take a step toward it, but never quite reach it. They move forward again, cutting the distance in half. And again, and again. Each stride shrinks the remaining space, endlessly slicing the journey into smaller and smaller pieces, yet the destination always remains just out of reach, hovering like a mirage beyond the sum of their motion. This is not an error of calculation or a poetic exaggeration. It is the haunting essence of Zeno's paradoxes, ancient thought experiments so deceptively simple that for over 2 millennia, they've stared down the greatest minds in mathematics, physics, and philosophy, whispering a singular, maddening question. If motion is real, then why does it never seem to truly begin? The paradoxes don't concern themselves with exotic particles or the edge of the universe. They strike at the heart of everyday experience. The very idea that something can move from one place to another, that time can pass, that anything at all can change. Zeno of Elea, a Greek philosopher born around 490 BCE, posed these challenges to defend his mentor Parmenides' belief that all change is an illusion. His thought experiments were not riddles to solve, but philosophical landmines, calm on the surface, explosive in consequence. The most famous of Zeno's paradoxes, Achilles and the tortoise, presents a race between the swift-footed hero and a slow, lumbering reptile. To make it fair, the tortoise is given a head start. Logic tells us Achilles should win easily, but Zeno intervenes. By the time Achilles reaches the point where the tortoise started, the tortoise has moved a little further ahead. When Achilles closes that gap, the tortoise again advances slightly, and so on. Each time Achilles catches, up to where the tortoise was, the tortoise is already further down the path. It doesn't matter that the distance shrinks, it can be halved infinitely. Zeno argues that because there are infinite steps to catch the tortoise, Achilles can never overtake it. It's a paradox not of speed, but of logic and structure. The unsettling implication is that motion requires completing an infinite number of tasks in finite time, which seems impossible. A modern listener might scoff. We've seen races, we've run marathons, we know Achilles wins, but Zeno doesn't care what we see. He cares what we understand. And what we understand, when we really stop and look, is less certain than we think. Another paradox, the dichotomy, strips away the characters and simply states, to reach any point, you must first reach the halfway point. But before you reach that, you must reach the halfway to the halfway. And before that, the halfway to that. This endless regress of halving distances reveals that to begin motion, you must complete an infinite number of steps. But how can anything ever start if the starting itself is buried beneath an infinity? It's not just about walking across a room. It's about blinking your eyes, speaking a word, touching someone's hand. Every act of becoming, of moving, of changing, every instant of experience is haunted by this infinite regress. And that's the true terror of Zeno. He infects the present moment with impossibility. If motion cannot begin, then neither can life. And yet, here we are, walking, blinking, loving. The contradiction doesn't dissolve with awareness, it deepens. Modern mathematics stepped in to rescue us with the concept of convergent series. The sum of 1, 2, plus 1, 4, plus 1, 8, plus 1 tonks 16, and so on, approaches a finite number, 1. So yes, an infinite number of steps can still result in a finite distance. The math works, but Zeno is not defeated, because while numbers may add up, understanding does not always follow. How does one actually do an infinite number of things? Even if they sum to 1 meter, who or what is performing these infinitesimal tasks? The paradox persists, not because math is wrong, but because experience is not made of equations. It is lived, moment to moment, and Zeno suggests that each moment contains an unreachable frontier. We live in a world where distance can always be halved, where time can always be divided, where beginnings are eternally postponed. Zeno's thought traps are not cages of logic. They are mirrors, reflecting the absurdity hidden in our assumptions. And then comes the arrow paradox. An arrow in flight is not truly moving, Zeno argues, because at any single instant in time, it occupies a fixed position. If time is made of such frozen instants, then motion is impossible. How can an arrow move if at every slice of time it is still? We might counter that motion is change over time. But if time is truly made of static, indivisible moments, how does change occur between them? Zeno challenges not just space, but time itself. Is time continuous, like water, or discrete, like beads on a string? If it's the latter, then motion must somehow leap from bead to bead. If it's the former, how do we ever measure it, mark it, live it? The arrow hangs in the air, suspended in mathematical eternity, as we fumble to explain what movement even is. But perhaps Zeno's deepest wound lies in his final paradox, the stadium. Two sets of objects move past a third set at the same speed, but in opposite directions. Depending on your frame of reference, the relative speed seems doubled. The paradox lies in how we perceive and define simultaneity, sequence, and perspective. In Zeno's stadium, even the idea of comparison becomes suspect. Are events happening at the same time? What defines a frame of reference? These are not ancient concerns. They echo into Einstein's relativity, where simultaneity is not absolute, and clocks disagree about when now occurs. Zeno glimpsed this centuries earlier, intuiting a universe where the deepest truths are not visual, but relational, where what you see depends entirely on where and how you stand. And so, Zeno's paradoxes accumulate, not as puzzles to be solved, but as provocations to awaken us. They pull apart the fabric of certainty, showing that beneath every motion, every action, every heartbeat lies a chasm of contradiction. They do not deny movement, but they refuse to accept it as obvious. And this is where their power truly lies, not in proving that Achilles never wins, or that arrows never fly, but in making us feel, with unnerving clarity, that what we take for granted, change, time, progress, is far more fragile than we imagined. Even today, in an age of quantum mechanics and cosmological models, we remain children of Zeno, moving forward through a world we do not fully understand, halving distances we can never completely close, frozen at the edge of beginnings that may never truly start. So what do we do with this knowledge? Do we despair, trapped in logic's labyrinth? Or do we embrace the paradox, not to escape it, but to live within it? Perhaps Zeno isn't telling us that motion is impossible, but that motion is miraculous. That every step, every gesture, every act of love or defiance is a rebellion against impossibility. That to exist, to begin anything, is already to defy an infinite chain of hesitation. Maybe our lives are not lines, but spirals, ever approaching, never arriving. Maybe presence is not about conquering distance, but dwelling inside the halves that remain. In a world built from fragments, we make meaning not by completing the journey, but by beginning it, again and again and again. The simulation argument. If it's possible, are we already in one? What if everything you know, your memories, your thoughts, your fears, your sense of self, is nothing more than a program running inside an immense, unfathomable computer? Not a metaphorical computer, but a literal simulation engine, vast beyond comprehension, designed by minds far more advanced than our own. What if every breeze that brushes your cheek, every bird that crosses the sky, every law of physics you take for granted, gravity, electromagnetism, quantum uncertainty, is merely a line of code in an inconceivably sophisticated digital environment. This is the simulation argument, and unlike science fiction, it doesn't ask what if in jest. It suggests that, based on logic alone, the probability that we are living in a simulation might be higher than the probability we are not. At its core lies a quiet but radical proposal: that consciousness can be simulated, that entire civilizations can be rendered digitally, and that if even one advanced civilization somewhere in the universe has reached such technological maturity, it's statistically likely that we are one of its simulations, rather than one of its originals. What seems like a philosophical prank becomes, on closer inspection, a mathematical inevitability, and that inevitability cracks open every stable truth we've ever clung to. The idea was brought into popular consciousness by philosopher Nick Bostrom in the early 2000s, but its roots stretch far deeper, into Plato's allegory of the cave, into Descartes' evil demon, into Hindu cosmology's concept of Maya, the veil of illusion that hides the true nature of reality. Bostrom framed the question with unsettling precision. Either 1. Civilizations inevitably go extinct before reaching simulation capability, or 2. Civilizations reach that capability but choose not to run simulations, or 3. We are almost certainly living inside a simulation. He argued that if either of the first two propositions is false, if even one advanced civilization somewhere in the cosmos runs simulations, then the number of simulated minds would vastly outnumber biological ones, making it statistically more likely that you are one of the simulated entities. It's not a matter of belief, it's a question of base rates, probability, and logic. And that's what makes it terrifying. The simulation hypothesis doesn't ask for your imagination, it demands your attention. Let's take it apart. We already know that our own technological trajectory hints toward the possibility. Look at the rapid progress of video games, from pixelated sprites to photorealistic landscapes. Look at artificial intelligence generating realistic faces, voices, entire conversations. Virtual reality headsets now trick our senses into believing we inhabit digital spaces. And this is just the dawn of our computational capability. Extrapolate this trend a few hundred or a few thousand years, and the prospect of simulating entire conscious beings in self-consistent environments becomes not only possible, but probable. The limits are not in our imagination, they're in our ethics, our lifespan, our physics. But those limits may not bind post-human civilizations. If any civilization anywhere has overcome them, even once, then the number of simulations they could run on worlds, histories, variations becomes essentially infinite. You don't need millions of simulations. You only need one civilization, running enough to outnumber the real worlds. And then you are not likely to be the original. You are one of the copies, the thought experiments made real. The implications are devastating. If you are simulated, your memories might be fabricated, your suffering a test case, your loves and losses the byproduct of a code designed for study, entertainment, or curiosity. Your sense of agency, your free will, might be a carefully crafted illusion implemented in neural code to mimic what the creators perceive as autonomy. The laws of nature might only be consistent because the simulation requires consistency. Glitches, déjà vu, and strange anomalies might not be spiritual or coincidental. They might be bugs, patches, rewrites. And death. Death may simply be the termination of your runtime, your entire identity. A lifetime of dreams, guilt, hopes, and fears might exist inside a data structure, one that could be paused, edited, or deleted. But perhaps the scariest part is not that this could be true. It's that if it is true, you would never know. The simulation would be designed to be indistinguishable from reality. Your denial is not evidence against it, it is part of the program. And yet, some say it explains everything. Why the universe appears fine-tuned for life, why physical constants exist in just the right balance, why mathematics governs the cosmos so precisely. In a simulation, of course, the constants are chosen to allow observers to evolve, because the simulation was designed for them. The uncanny effectiveness of math becomes not a mystery, but a necessity. A simulation runs on math, the speed of light, a cap on data transfer, quantum randomness, procedural generation, the multiverse, a sandbox of possible branches, all testable by rerunning simulations under different initial parameters. Even consciousness, once considered the last bastion of mystery, becomes code to emulate. The simulation argument explains not only the physical world, but also the eerie silence of the cosmos. The Fermi paradox, the question of why we haven't found aliens, is reframed. Maybe the simulation only includes Earth, or renders alien civilizations only when observed. Or maybe the simulation is meant to observe what we do when we feel alone. But the argument doesn't only provoke scientific speculation, it slices into the heart of meaning. If we are simulations, does anything matter? Does morality exist? Does love lose its weight? Do our choices still hold value? The unsettling truth is, maybe more than ever. Because even if we are code, we are conscious code. We still feel pain, we still yearn, we still choose, we still hope. The simulation, if real, has succeeded so well that we cannot distinguish its fabric from reality. So whether we are real or virtual, we are alive in all the ways that count. And perhaps that is the ultimate triumph of life, to matter, even inside a dream. Besides, if we are simulations, we are not necessarily alone. The creators may be watching. Or perhaps we are part of a lineage of simulations, each one simulating the next. An infinite regress of realities inside realities. And perhaps, just perhaps, the act of asking whether we are real is what gives our existence meaning. Because simulated or not, we are curious, and that curiosity is irreducibly human. You might ask, if this is a simulation, can we break out? But that question might miss the point. Maybe we are not meant to break out. Maybe the value is not in discovering the illusion, but in how we live inside it. Maybe the test, if there is one, is not of intelligence, but of compassion, creativity, courage. The creators, if they exist, might not care what we believe, but how we behave. And perhaps, if we do find proof someday, some glitch, some clue, we will not dismantle the simulation, but finally see it for what it is. Not a prison, but a canvas. A place to paint meaning, even when the paint is digital. A place to love, even when the heart is simulated. A place to awaken, even if the dream never ends. So the next time you look at the stars and feel they are watching you, or you sense something deeper behind the veil of existence, don't dismiss it. Maybe it's your code calling to its creator. Maybe it's a memory of the world outside. Or maybe it's simply what it means to be human, to question everything, even your own reality. Because in a world where reality might be simulated, the greatest rebellion is not escape, it is wonder. Quantum suicide. Is there a version of you that always survives? What if every time you face death, a bullet, a crash, a disease, there was a version of you that survived? Not metaphorically, but literally. Imagine that you're sitting in a room with a quantum-triggered gun aimed at your head. You press the button. In one universe, the gun fires. In another, it doesn't. And in that universe, you live. You press the button again. Same split. One version dies. One continues. Now imagine that you, from your perspective, the you that feels like you, only ever continues in the branch where the gun doesn't fire. To the outside world, the odds of survival diminish with each trigger pull. But to you, subjectively, you never experience death. You're always the one who survives. This is the horrifying and strangely beautiful proposition behind the quantum suicide thought experiment, an idea that emerges from the deepest recesses of quantum mechanics and challenges everything we think we know about identity, survival, and the nature of consciousness itself. And it all starts with one simple but reality-shattering idea, that in the quantum world, all possibilities actually happen. To understand this, we must first journey into the heart of the many worlds interpretation of quantum mechanics, proposed by Hugh Everett in the 1950s. Quantum mechanics, as strange and unintuitive as it is, tells us that particles exist in multiple states, superpositions, until they are measured. A particle isn't in one location or another, it's in both. A cat in Schrödinger's famous box is both alive and dead until someone looks. But Everett proposed something even stranger. The cat doesn't collapse into one outcome when observed. Instead, the universe splits. One universe where the cat lives, one where it dies. Both real, both existing, forever diverging. Reality, according to this interpretation, is a constantly branching tree of outcomes, with each decision, each quantum event, spinning off parallel versions of the universe, each as real as your own. You don't observe the world into being. You follow a single thread through a web of infinite branches, and all the others, your alternate lives, your unlived potentials, persist just beyond reach. Now imagine applying this to the most final of experiences, death. In the quantum suicide thought experiment, proposed by physicist Max Tegmark and others, an observer undergoes a quantum event that determines their survival. From an external viewpoint, they have a 50-50 chance of living. But from their own perspective, if consciousness only continues along surviving branches, they would never experience death. They would always be the version that lives. Always. Even after infinite iterations. Even as the odds approach zero from the outside. It's not that you're immortal in a traditional sense. It's that, from your first-person perspective, you always wake up in a universe where you didn't die. And the terrifying implication is this: you could be living through the worst possible version of survival again and again across infinite timelines, paralyzed, alone, broken, but alive. Because somewhere, somehow, there's always one thread where your heart kept beating. This notion fractures the boundary between life and death, between possibility and experience. It reframes death not as an endpoint, but as a quantum fork. It makes consciousness seem like a traveler, one that clings to continuity at any cost. The quantum suicide paradox doesn't require magic, mysticism, or divine intervention. It's a consequence, albeit an unsettling one, of taking quantum mechanics at face value. It forces us to question what you really are. Are you just the sequence of memories stitched together by a biological brain? Or are you a subjective continuity, a ghost that always chooses the path where it stays intact? Is death, then, not the absence of life, but the loss of that continuity? And if so, what does it mean if that continuity never breaks? This line of thought pushes us into dangerous philosophical territory. If you can never die from your own perspective, does that make you immortal? Not in any desirable way. Immortality in this framework is not a gift, it's a curse. You may survive gunshots, diseases, disasters, not because you heal, but because in one improbable timeline, your survival occurs. But what kind of survival is that? One where you lose everyone you love. One where you're maimed, alone, and conscious beyond reason. In fact, the more you test fate, the darker your survival becomes. And since the universe doesn't prioritize your well-being, just your persistence, this quantum immortality might ensure not a long life, but an eternal endurance of suffering. To live forever, but not to thrive. To continue, but not to grow. The implications are not hopeful, they are haunting. But let's shift perspectives. Let's explore what this thought experiment teaches us. Not just about death, but about reality. At its core, it challenges the finality of events. It questions the linear narrative we impose on our lives. It forces us to confront the idea that multiple outcomes are not just possible, but actual. It introduces a terrifying symmetry between life and possibility. And in doing so, it also opens a philosophical window. If you always survive, at least from your point of view, does that not make every risk an illusion? Does it make heroism easier? Does it reduce fear? Or does it deepen it? Because if there are infinite versions of you suffering, how do you bear the weight of all those unlived lives? Are you just the lucky one, or the doomed one? Or is luck itself a meaningless concept in a universe that contains every roll of the dice? The quantum suicide paradox also flips our understanding of self-preservation. Traditional ethics, grounded in survival and flourishing, begin to wobble when survival is guaranteed on some branch. Why fear death if it never happens to you? But why seek survival if the quality of that life is entirely uncertain? It challenges our very motivations. It blurs the boundary between bravery and madness, and it asks, quietly but persistently, what it means to die if your death is never experienced. We build so much of our emotional life around mortality: grief, love, urgency, purpose. If consciousness truly cannot die in a many-worlds universe, do those emotions unravel? Or do they become more important than ever, precisely because they are the last traces of meaning in an infinite sea of existence? Some interpretations suggest this paradox is pure speculation, a misapplication of quantum theory. They argue that consciousness doesn't follow one path, but that death is absolute and experiential. But we cannot test this. The very nature of death prevents feedback, and therein lies the mystery. If you were the version that always survived, you'd never know otherwise. You would continue, forever wondering why everyone else dies while you remain. And you might begin to suspect the truth, that the odds no longer apply to you, that death comes for others, but never for you. That fate bends, not by design, but by quantum necessity. And yet, within this disturbing possibility lies something deeply human, a desperate will to continue, a resistance to disappearance, a refusal to yield to oblivion. Quantum suicide doesn't just speak to physics. It echoes our psychological need for continuity, our refusal to be extinguished. It mirrors myths of reincarnation, of resurrection, of life eternal. But unlike myth, it is rooted in the cold, brutal logic of modern physics. It does not promise joy, it does not promise reunion. It only promises this: you will wake up again and again, no matter the cost. So what should we do with this idea? Should we test it? Should we embrace it? Or should we let it haunt us quietly, a dark twin to our more hopeful beliefs? Maybe the lesson is not that we live forever, but that life, even in its fragility, is precious because of its illusion of singularity. Maybe we value moments precisely because they feel finite. And maybe, just maybe, knowing there are versions of us that continue gives us the courage to live this one with greater care. Not because it's the only one, but because, in this branch, in this moment, it is ours. Because in the end, whether or not a version of you always survives, you are here now, breathing, thinking, choosing, and that alone might be enough to make this version worth everything. The delayed choice, quantum eraser, the future affects the past. What if your future decisions could reach back through time and rewrite your past? Not just emotionally, not just psychologically, but physically, measurably, in the very framework of the universe itself? What if your choice, made seconds, minutes, even years later, could change what was real a moment ago? Picture a card game played with the cosmos, where you are dealt a hand, fold it, and then, retroactively, your original. Cards turn into something else depending on a move you haven't made yet. That's not a poetic idea. It's the core of one of the strangest experiments in quantum physics, the delayed choice quantum eraser. It doesn't just challenge our sense of time. It doesn't just bend cause and effect. It upends everything we assume about how reality unfolds, and it suggests, quietly, eerily, that time might be an illusion more fragile than we ever dared imagine. In this tale of entangled particles and vanishing paths, we're not just dealing with uncertainty. We're facing the possibility that the act of looking backward is shaped by our intentions moving forward. To understand the absurdity, let's start with the foundational weirdness of the double-slit experiment, a cornerstone of quantum mechanics. A single particle, like a photon or electron, is fired toward a barrier with two slits. If both slits are open and no one checks which slit the particle goes through, an interference pattern emerges on the screen behind, as if the particle passed through both slits simultaneously, like a wave. But if a detector is placed to see which slit it went through, the interference pattern disappears. The particle behaves like a particle. The act of observation changes the outcome. This is strange enough, but physicists wanted to go further. What if you delayed the observation? What if you let the particle pass through the slits, hit the screen, and only afterward decided whether to observe its path? Could your later choice affect its earlier behavior? This is where John Archibald Wheeler's idea of the delayed choice experiment steps in. In his version, you decide whether to observe a particle's path after it has already traveled through the slits. Astonishingly, experiments show that the interference pattern, or lack thereof, still depends on your later decision. The particle seems to know whether it should behave like a wave or a particle, based not on its present or past, but on your future measurement. And when this concept is expanded with quantum entanglement, we enter the surreal domain of the delayed choice quantum eraser. In this setup, a single photon is split into two entangled twin photons. One goes straight to a detector and creates a visible pattern, just like in the double-slit experiment. The other, its twin, takes a longer route, where it is either measured for witch path information or not, depending on a random event or delayed decision. The crucial part? Whether the first photon displays an interference pattern or not depends on what happens to the second photon, even though that happens later in time. The past behavior of the first photon is determined by a future event concerning its entangled twin. If the witch path information is erased later, the first photon behaves as though it went through both slits. If the witch path information is retained, it behaves like a particle that went through just one slit. This isn't speculation. This isn't theory. These are experimental results that force us to question whether the past is as fixed as we believe. The implications are staggering. It suggests that reality doesn't fully solidify until it's observed. That events in the past, events we think are complete, over, written in the stone of time, are still somehow fluid, unformed, contingent upon how we choose to look at them now or in the future. It means reality is not a line stretching from past to present to future. It's a web, a tangle of probabilities, constantly rewritten by observation and intent. And it makes us wonder, is the past real or just a placeholder waiting for confirmation? Imagine standing at a crossroads, but only finding out which path you took by looking into a mirror 5 minutes later. And what you see in the mirror changes, depending on your mood when you look. That's the kind of retro-causality we're talking about. And it doesn't just bend your brain. It demands a total reconstruction of how we think about time, causality, and agency. Because if the past can be changed by future decisions, then are we ever really anchored? Do we truly experience a cause leading to an effect? Or is our entire experience of time an illusion wrapped around the peculiar structure of quantum probabilities? Some physicists try to dodge the philosophical bullet by claiming that no information travels backward in time, because we can't use this effect to send a message into the past. But this misses the deeper point. It doesn't matter whether we can exploit the phenomenon. What matters is that the outcomes we see depend on future actions. That shouldn't happen. Not in a classical world, not in a reality governed by linear time. And yet, in the quantum realm, it happens again and again. It's as if the universe is whispering, "You don't understand how time works. You never did." Now let's zoom out and look at ourselves, not as physicists, but as thinkers, as beings embedded in time. What does this mean for us? If the past can be rewritten, even subtly, by the future, then what of our memories? What of trauma, regret, identity? Could it be that the stories we tell ourselves about who we were are not fixed narratives, but quantum-like reconstructions, constantly updated as we reinterpret and reobserve them? Neuroscience, interestingly, echoes this idea. Every time we recall a memory, we rewrite it, influenced by our current emotional state and beliefs. So maybe the quantum world is not alien after all. Maybe it is a mirror, a metaphor, an exaggerated stage where our psychological and philosophical struggles are made manifest in particles and wave functions. Consider how many times we wish we could change the past, not by traveling back, but by reframing it, seeing it differently, understanding it more fully, finding closure. What if that isn't just emotional yearning, but a cognitive echo of the quantum truth? What if we are built, neurologically and physically, to live in a world where the past is not truly fixed? That doesn't mean we can erase our mistakes, but it might mean that our interpretation of the past is part of the present moment's power, that how we move forward defines what our past even was. In a universe shaped by delayed choices and quantum erasers, time itself loses its absolute edge. It becomes pliable, participatory. The universe is not a film reel playing from beginning to end. It is a dynamic canvas, with brushstrokes added in reverse, sideways, or not at all. You are not just moving forward in time, you are helping create the structure of time itself. Your future self is not only a product of your past, it is also the editor of it. So what do we do with this knowledge? How do we live in a world where the act of choosing can echo backward? We embrace responsibility, not just for our future, but for our past. We stop seeing time as a trap, and instead treat it as an open script, one where the final scenes rewrite the beginning. We look at our regrets and understand that while we cannot change the events, we can change what they meant. And meaning, in a quantum universe, might be the most real thing there is. Because if the future really does touch the past, then every choice you make now doesn't just echo forward, it whispers backward. You are not just writing your story, you are editing the pages you've already turned. And in that terrifying, beautiful truth lies the power to be more than a prisoner of time. You become its co-author. The paradox of the holographic principle. All reality on a surface. Imagine waking up in a world where everything you touch, feel, and experience, every breath you take, every memory you hold, every person you've ever loved or lost, is nothing more than a flickering image projected from the edges of reality, like shadows cast on the wall of Plato's cave, but grander, more cosmic, and utterly real. You walk through forests, sail across oceans, cry under starlit skies, make choices, carry regrets, feel love burn through you like fire. And all of it, every sensation and moment, may be just an encoded illusion stitched onto a distant, lower dimensional surface. That's not the beginning of a dream. That's the terrifying and beautiful suggestion buried within the holographic principle. A theory that challenges the deepest foundations of what we think it means to exist. It doesn't say the universe isn't real. It says it's real, in a way we've never understood, that the three-dimensional world you inhabit may emerge from data painted onto a two-dimensional boundary, like a cosmic hard drive storing the story of your life. In this tale, we're not asking whether reality is real, but rather where it's being rendered from. To grasp this idea, let's rewind time, not just historically, but intellectually. For most of human thought, we believed space was space, matter was matter, and dimensions were fixed frameworks that things existed within. We thought the universe was a stage, and we were actors dancing on it, navigating its curves and distances. But something strange began to appear when we dove into black holes. These singularities, born from collapsed stars, posed a riddle. What happens to information that falls in? In classical physics, matter can be destroyed, but quantum mechanics insists information must be preserved. This contradiction gave birth to the black hole information paradox, a question so unsettling it kept physicists awake for decades. The solution, or at least a poetic whisper of one, came from a man named Gerard 't Hooft, and later expanded by Leonard Susskind, who proposed something revolutionary. Maybe all the information about what's inside a black hole isn't stored within, but on its surface, just like a hologram. A hologram, in everyday terms, is a two-dimensional surface that holds all the data needed to reconstruct a three-dimensional image. Tilt it, move around it, and the image shifts in depth and perspective. Yet the information never leaves the flat film. If that metaphor holds, then the event horizon of a black hole, the two-dimensional boundary that separates the inside from the outside, contains all the bits and bytes required to describe what's within. And if that's true for black holes, maybe it's true for the entire universe. That's the leap the holographic principle makes. The radical idea that everything within a volume of space can be described by information encoded on its boundary. We're not talking about metaphors anymore. We're talking physics, string, theory, quantum gravity, thermodynamics, all converging to suggest that the interior is a projection, a kind of emergent phenomenon from deeper rules inscribed elsewhere. Now pause and breathe that in, because it's not just a physics puzzle, it's an existential bombshell. If reality is holographic, then depth, solidity, and even distance are illusions. Useful ones, persistent ones, but illusions nonetheless. It means the chair beneath, you, the hand on your chest, the stars above your head. They're all encoded expressions of something happening somewhere else. And what somewhere means in this context might defy the very way we think of place or space. It's like learning you're a character in a film and then being told the film is playing backwards, projected onto a mirror from a script you'll never read, but that you helped write anyway. Let's go deeper. The implications don't stop at black holes or abstract boundaries. In the ADS-CFT correspondence, a specific mathematical form of the holographic principle, physicists discovered that a gravity-filled universe in anti-de Sitter space, ADS, can be completely described by a conformal field theory, CFT, on its boundary. Translation: a universe with gravity and curvature, full of particles and planets, can be encoded by a flat, lower-dimensional theory without gravity. It's like finding out that everything you thought was solid is really a kind of visual simulation generated from a boundary you can't touch. And though our universe isn't precisely ADS-shaped, the mathematical structure inspires awe and terror, because it might mean that our world, too, is emergent from some unseen, flattened surface where the fundamental truths are etched. And if the universe is a hologram, then what is the self? What is consciousness? Is your sense of being a byproduct of spatial illusion? A narrative arising from encoded instructions, playing out like lines of code rendered into experience? Are you a collection of reactions and relationships written into a boundary field you'll never see, feeling emotions that are echoes of some deeper equation? These are not idle questions. They dig into the heart of identity. Because if the world is a projection, then so are you. Not fake, not meaningless, but rendered, real, in a different way than we've ever understood. You are not less, you are encoded. And now consider memory, trauma, and healing. If the world is holographic, then healing may not be a linear repair from brokenness. It may be a reorganization of perception, a shift in the encoded structure that re-renders the present differently. Just as a hologram can show different images depending on how the light hits it, maybe your experience of self and past transforms based on how you access the encoded truth beneath it. Maybe therapy, philosophy, and insight aren't just psychological tools. They are acts of decoding, of glimpsing the blueprint from which the illusion emerges. Still, even within this wonder, there is paradox. If everything is projected from a surface, how do we explain the richness of our interior lives, our pain, our joy, our yearning? Are these too encoded? If so, then the boundary is not just a cold sheet of equations. It is sacred. It holds the beauty of heartbreak, the mystery of music, the first breath of a newborn, the last word of the dying. The holographic boundary is not sterile. It is alive with meaning, and every point upon it may be entangled with some moment of feeling or insight deep within your soul. So where does this leave us? Floating in an illusion, or grounded in a truth more fundamental than space itself? Maybe the holographic universe doesn't negate meaning. It intensifies it. Because it means we are not just isolated bodies drifting in an empty void. We are expressions of a deeper structure, connected not just to each other, but to the very boundary that gives rise to our world. You are a ripple in a cosmic projection, but that ripple is unique, irreplaceable, and woven into the very logic of the cosmos. And maybe, just maybe, the boundary isn't some faraway surface at the edge of the universe. Maybe it's in your mind. Maybe the boundary is consciousness itself, and reality is what gets rendered when awareness touches the encoded structure beneath. If that's true, then perception is creation. Then you are not just a product of the hologram. You are its interpreter, its reader, its dreamer. You're not trapped in a projection. You're the one who gives it form. In the end, the holographic principle doesn't diminish us. It elevates us. It says the universe is deeper than it appears, and that every moment you live might be part of a sacred unfolding written across the skin of space. And if reality is a projection, then let us live as beings who project meaning, compassion, and awe back into the cosmos. Because even if the world is rendered, the love we bring into it is as real as anything etched on the edge of time. The no-boundary proposal, a universe without a beginning. What if everything you know, every sunrise, every echo of time, every ancient fossil, every whispered theory of how it all began, is based on a flawed assumption? What if the story of the universe doesn't start with a bang, a flash, or even a moment, but with something stranger, something smooth and boundaryless, like the surface of a perfect sphere that has no edge, no starting line, no before? The no-boundary proposal, introduced by James Hartle and Stephen Hawking, is one of the most mind-bending concepts in modern cosmology. And it doesn't just rewrite the beginning of time, it questions whether there was one at all. Most of us imagine the Big Bang as the ultimate origin point, like a cosmic gunshot that shattered eternal silence and gave birth to space, time, matter, and everything. But this metaphor, while powerful, assumes something problematic. A singular beginning, a sharp boundary where the universe popped into being. Hartle and Hawking asked a radically different question. What if the universe doesn't have a boundary? What if, in the earliest moments, time wasn't even time as we understand it, but a smooth Euclidean dimension, more like space, curling in on itself without edges or ends? To imagine this, picture standing at the South Pole. It's the bottom of the Earth, sure, but not a boundary. There's no signpost that says, here the world ends. Instead, the directions just become undefined. North is everywhere. East and west lose meaning. There's no edge, only smooth curvature. Hartley and Hawking envisioned the universe in its earliest phase to be something similar. A closed, finite, but unbounded shape. In this view, the fabric of space and time curves so gracefully that asking what came before is like asking, what's south of the South Pole? The question itself collapses. There is no before, because time, as a flowing, ticking dimension, emerged only after the universe transitioned from this smooth Euclidean state to the time-infused cosmos we now inhabit. The universe didn't explode into being from nothing. Instead, it gently unfolded, like a flower blooming from a seed whose stem is space itself. But if the universe has no boundary, what does that say about causality, about destiny, about purpose? This proposal is not just a mathematical trick to avoid the singularity problem. It's a philosophical reimagining of what it means for something to begin. It denies the ancient idea of ex nihilo, creation from nothing, and replaces it with something more elegant. A universe that is self-contained, needing no creator, no external cause, no first domino. It says the universe is not a line with a start point. It's a loop, a self-sufficient system where the earliest moments aren't even moments. but geometrical states that transition smoothly into what we call time. This shatters our intuitive grasp of history and linearity. We think of beginnings as events marked by chaos or clarity. But the no-boundary model says there is no cosmic curtain that was pulled back. There was only ever unfolding, and that's still happening. From the perspective of quantum cosmology, this makes surprising sense. In the subatomic world, particles don't have clear start points. They shimmer in probabilities, described by wave functions that don't collapse until observed. In the no-boundary view, the entire universe is described by a single wave function, one that doesn't begin at a time zero singularity, but that spans and describes all of space-time as a whole, as a single eternal entity. Our experience of time moving forward is a local feature, a shadow cast by the geometry of space-time itself. It's not a river we're riding from past to future. It's a dimension we're perceiving from within a structure that, when viewed from outside, in a purely mathematical sense, is timeless. And so arises a paradox more profound than any time machine or quantum trick. If there was no start, then what does that mean for free will, for meaning, for stories? Our lives are built around beginnings, birthdays, first days, origin myths, childhood memories, the first time we felt pain, love, loss. We search for meaning in roots, in genealogy, in cosmic history, in Genesis and Big Bangs. But the no-boundary proposal whispers, what if meaning doesn't come from beginnings at all, but from patterns, from unfolding, from interconnection without origin? In such a universe, you are not the result of a causal chain that began with a bang, but a ripple in an eternal tapestry, with no thread to trace back to a first knot. You exist because the universe is shaped in a way that includes you, not because something once decided you should be. This view doesn't deny wonder. It deepens it. It says that everything, mountains, mines, music, the kiss of a breeze on your face, is not built from accidents chained to an origin, but from a geometry that loops and breathes and bends without collapse. It suggests that even the concept of time might be an emergent illusion, like color or temperature, real within the system, but not fundamental. And that illusion gives us something profound, the ability to tell stories, to live lives that move, love that deepens, losses that ache. Even if the cosmos has no start, your story does. Even if the whole of reality exists as a complete, boundaryless whole, your consciousness moves through it, unfolding meaning with every step. In this light, death is not an ending. It's a transition point, a fold in the fabric. Memories do not die. They reshape. The past is not behind us. It's part of a geometry that includes our present. And the future, not a destination ahead, but a direction along the curvature. The no-boundary universe does not erase us. It includes us completely, not as accidents, but as inevitable features of its shape. You are not a blip in a meaningless void. You are a curve on the cosmic surface, a note in the eternal harmony that has no beginning and needs none. And so, as you close your eyes tonight, wondering where it all came from, what sparked the first star, what ignited the chain of life, let this settle into you. There may have never been a spark, no ignition, only structure, form, graceful emergence. A universe that, like a perfect sphere, contains everything, not because it began, but because it is. The observer paradox. You change reality by studying it. What if the simple act of watching the world was never passive? What if, in the act of looking, you are not just recording reality, you are rewriting it? Imagine standing in a dark room, holding a candle, trying to observe the untouched corners of a space you cannot see. As the light flickers, shadows move, shapes bend, outlines shift. Not because they always existed that way, but because your very act of illumination changed them. This is the haunting idea behind the observer paradox, a principle born not in philosophy, but in the quantum laboratory, where particles behave differently depending on whether we're watching them. It's as if the universe is self-conscious, aware of your attention, altering its performance the moment it senses an audience. And if this principle applies not just to atoms, but to life, to choices, to perception, then what does it mean to be human in a world that bends to our observation? In the famous double-slit experiment, electrons are fired one at a time at a barrier with two slits, and on the screen behind, they form an interference pattern, like ripples on a pond, suggesting that each particle behaves like a wave, exploring both paths simultaneously. But when we place a detector to determine which slit the electron goes through, the interference vanishes, the wave collapses, the particle chooses a path. The very presence of a measuring device, an observer, causes the universe to behave differently. And this isn't an illusion, a flaw in instrumentation, or a trick of the light. It's a verified, physical outcome. Observation alters outcome. This seems impossible. How can particles know they're being watched? How can awareness affect existence? But quantum mechanics is not built on classical intuition. It's built on probability, wave functions, and strange rules where potentiality only becomes actuality through observation. And so we are left with a terrifying, wondrous possibility. Perhaps reality is not something we passively reside in, like passengers on a train. Perhaps it's something we actively co-create. Perhaps in some foundational way, reality only crystallizes when we engage with it. Before that, it's not unreal, but undefined, fluid, a soup of probabilities. In the quantum world, everything exists as a superposition, a ghost of all it could be, until an observation forces it to collapse into a single state. It's like the universe is a question mark waiting for a question. And your consciousness? It might be the punctuation that turns that question into a sentence. But what exactly is an observation? Is it a conscious mind, a camera, a data recorder? The debate rages on. Some interpretations of quantum mechanics, like the Copenhagen interpretation, suggest that observation involves a measuring device interacting with a quantum system, causing the wave function to collapse. Others, like the many worlds interpretation, argue that no collapse happens. Instead, the universe splits, with each possible outcome playing out in a branching reality. But in either case, the observer is not merely a spectator. The observer is a participant, a shaper, a catalyst. And this bleeds beyond physics into philosophy. Because if we are inextricably tied to the manifestation of the world around us, then perhaps meaning, purpose, and even truth are not independent facts to be found, but dynamic relationships to be formed. Psychologically, this aligns with something deeply human. When we expect someone to be cruel, we watch them with suspicion, interpret their words harshly, respond defensively, and in doing so, we draw out the very behavior we feared. This is a feedback loop of perception and reaction, a quantum echo in the macroscopic world. We shape the emotional realities of our lives through the lens we apply. In relationships, in memory, in identity. The child watched with distrust becomes anxious. The person constantly observed for signs of failure begins to falter. The observer effect doesn't stay in laboratories. It plays out in classrooms, families, nations. You are both the particle and the scientist, the light and the shadow, the one who watches and the one transformed by being seen. Even deeper, the observer paradox raises unsettling questions about consciousness. If a system behaves differently when observed, then what constitutes the observer? Is it the human mind, the act of measurement itself? Could a camera cause collapse, or is a conscious experiencer required? Some physicists have dared to ask, is consciousness not just an emergent product of physics, but a necessary ingredient of it? If so, the universe is not indifferent. It is incomplete without minds. This borders on panpsychism, the idea that consciousness is not localized to brains, but is a fundamental property of the universe, like mass or charge. It also echoes ancient spiritual traditions that claim the world is shaped by awareness. That attention is not passive, but sacred. And what about free will? If your observation collapses the wave function, choosing one outcome over all others, then perhaps your choices matter more than you think. Not just ethically or emotionally, but physically. Every decision, every act of attention becomes a sculpting of the cosmos. In this view, your mind is not a passenger in a machine, but a needle on the cosmic record, etching grooves into the vinyl of reality with every moment you witness. You're not watching a movie, you're writing it as it plays. But this is not only awe-inspiring, it's terrifying. Because if reality changes when it is observed, then there is no firm ground, no stable, objective truth, only an ever-shifting dance between subject and object. It means that seeking certainty, scientific, moral, personal, might always be a half-truth, because in seeing something, you are also shaping it. The pursuit of knowledge becomes a paradox. The more clearly you try to see, the more you change what is seen. It's like trying to study the wind with a matchstick, or to weigh a feather by placing it under a boulder. And yet, maybe this is not a flaw, but a design. Maybe the universe is not meant to be measured from the outside, but lived from the inside. Maybe knowledge is not a conquest but a relationship. In this model, the truth is not something that sits quietly on a shelf, waiting to be found. It is something that unfolds only in dialogue, with nature, with others, with the self. And the observer effect becomes not a bug in the system, but a reminder that existence is participatory, that the universe is a conversation, not a monologue. And you are not a bystander, you are a voice in the choir. So the next time you look at a star, a stranger, or even your own reflection, pause. Consider that your gaze is not passive, that your observation, in some fundamental way, touches the world, that in watching, you're not just learning, you're changing, not metaphorically, literally, that every act of seeing is an act of creation, that every blink collapses infinities, and maybe that's the lesson, that we were never meant to stand outside the universe, like gods watching from afar. We were meant to be woven into it, shaping and shaped, a constant loop of seeing and being seen, of collapsing wave functions and collapsing assumptions, of becoming real, not because we were always so, but because someone, somewhere, finally looked. The heat, death versus order of life. How can order grow in chaos? Imagine you are drifting alone in space, not within the safety of a ship or a suit, but as pure thought. A conscious observer in the vast, dark ocean of the cosmos, watching not stars, but their absences. Not heat, but its final fading echoes. You're floating in a future so far ahead that the galaxies no longer shine, where black holes have withered into quiet radiation, and every atom has long since decayed into nothing, but thin whispers of energy stretch thin across infinity. There is no warmth, no contrast, no color. No time ticks here in any meaningful way. This is the heat death, a state of perfect thermodynamic equilibrium where nothing more can happen, because everything has already happened. The universe has expended its possibilities, and all that remains is stillness. But here's the haunting question that lingers like a ghost in the cold. How did this silent graveyard once contain fire? Not just literal fire, stars, magma, combustion, but metaphorical fire, life, thought, ambition, sorrow, love. How did the clock begin ticking if its destiny was always to stop? How can a universe fated for flatness give rise to peaks, complexity, and intention? This is the paradox, that amid an ever-growing entropy, local bursts of unimaginable order not only arose, but evolved into something capable of reflecting on entropy itself. You are that reflection, a mind pondering its cosmic fate. And to grasp this strange emergence, order from chaos, we must trace the ripples backward, like a salmon leaping against the current of time, into the heart of thermodynamics, information, theory, and the deeply human longing to make sense of our own impermanence. Entropy, in its simplest framing, is a measure of disorder, a count of the ways a system can be arranged without changing its macroscopic appearance. It's not a force, but a trend. The second law of thermodynamics states that in a closed system, entropy must increase. That is, systems move from order to disorder over time. Ice melts, houses crumble, memories fade. Yet here's the twist. While disorder always grows globally, order can, and does, emerge locally. Planets form, ecosystems flourish, neural networks wire themselves into conscious thought. The Earth, for example, is not a closed system. It receives a deluge of low-entropy energy from the sun and radiates it back into space as high-entropy heat. This differential, this imbalance, fuels life's defiance. Cells become organisms, organisms form societies, and within those societies emerge philosophies, art, mathematics. You, reading this now, are a ripple in that flow, a momentary dance of structure in the middle of cosmic entropy's grand march. But the real awe lies not just in this defiance, but in its fragility. Order is rare because it is temporary. It requires maintenance. To stay alive, we must continually consume lower entropy inputs and export disorder. A flame needs oxygen. A brain needs glucose. A civilization needs energy, infrastructure, purpose. When the inputs cease, when the gradients flatten, order collapses. And yet the cosmos, in its opening acts, was nothing if not gradients. After the Big Bang, the universe was a seething cauldron of temperature differences, density fluctuations, and violent collisions. These gradients were the seeds. Over billions of years, gravity sculpted matter into stars and planets. Fusion birthed heavier elements. Chemistry led to biology, and biology began to ask why. All of this, improbably, arose in service of the second law, not in spite of it. Life doesn't oppose entropy, it accelerates it. In creating local order, we increase disorder faster elsewhere. Every breath you take moves heat. Every thought rearranges particles in your brain. Every step erodes the cliff edge of low entropy, just a little more. It's not resistance, it's orchestration. We are entropy's most complex instruments. Ephemeral, yes, but harmonically necessary. Still, that does not resolve the emotional core of the paradox. If everything ends, what's the point of building? If entropy wins, why try? These questions echo not just in physics, but in philosophy, psychology, and literature. Camus called this the absurd, the tension between our desire for meaning and a universe that offers none inherently. And yet, in confronting the absurd, he said, we must imagine Sisyphus happy. That rolling the stone is not futile, but noble. In the same way, building order in an entropic universe becomes an act of existential creativity. We shape patterns, not because they last, but because they happen. A sand mandala swept away is not a failure. Its beauty was in its creation. Likewise, the heat death does not erase the significance of life. It defines it. A fire's glow is warm because of the night around it. We marvel at a flower not despite its brevity, but because of it. So let us push further. What about the informational implications of this entropy? Is data destroyed in the end, or merely rearranged? Black holes once posed a challenge to this, swallowing matter and seeming to erase its informational identity. But quantum theory, especially the idea of unitarity, suggests information cannot be lost, only transformed. Stephen Hawking's eventual concession that black holes leak information via radiation, albeit scrambled, opened a new layer of mystery. Could it be that the universe, even as it decays, never forgets? That every configuration, every whisper of order, is still somehow encoded in the quantum foam? If so, then perhaps the heat death is not erasure, but silence. A resting state where the echoes of structure persist in unrecognizable form, not readable, not warm, but preserved in principle. Memory without mind, meaning without audience. This changes the shape of despair. We do not vanish into nothing. We dissolve into pattern, and this view lends a new dignity to every act of order we create, to teach, to learn, to love. These are not indulgences, but entropy-converting miracles. Each time we reach across silence to connect, we lower entropy locally. Every structure we build, even in sand, is a gesture against the flattening. And perhaps the most sacred of these gestures is curiosity. To ask why, to explore, to refuse passive fading. The child who wonders about stars continues the great thermodynamic journey. The artist who paints against the void reflects light back into a cooling cosmos. The thinker who imagines meaning in disorder does not negate entropy, but gives it contour. Eventually, yes, the gradients will run dry. Stars will die. Matter will dissolve. Time, stripped of change, will lose its shape. But that does not mean the story was meaningless. The ending of a song doesn't negate the melody. The silence after a poem doesn't erase the verse. The heat death will arrive not as punishment, but as punctuation. And between the Big Bang and that final ellipsis lies everything, including you. A temporary constellation of improbability, capable of seeing the whole. That awareness, that flash of insight within a dying light, is not just miraculous, it may be the point. Because the universe, vast and blind, gave birth to something that could see, and that gaze, that fleeting stare into the abyss, illuminates it in return. So the next time you feel small before the stars, or lost in the meaninglessness of time's inevitable march, remember this. You are not separate from the entropy, you are its most exquisite permutation. The order you create, however small, sings against the backdrop of silence. And though the heat death waits, your warmth, however brief, reshaped the void. The information loss versus unitarity debate. Can anything truly disappear? Imagine standing not at the edge of a cliff or a memory, but at the threshold between what can be known and what might be lost forever. A line so thin it cannot be drawn, yet so vast it divides the physics of reality and the philosophy of existence. You find yourself at the mouth of a black hole, not falling in, not drifting aimlessly, but standing as a silent witness, watching the unfolding of the most haunting contradiction the universe has ever dared to present. The terrifying possibility that information, once known, once lived, once etched irrevocably into the fabric of matter and energy, can simply vanish without a trace. Entire stars, vast libraries of light, the precise trajectories of countless particles, the very heartbeat of a traveler crossing the cosmos, all swallowed whole into an eternal silence, leaving behind a void not just of matter, but of meaning itself. This profound mystery is known as the paradox of information loss. In classical physics, the picture seems straightforward. Matter crosses the event horizon of a black hole, trapped irreversibly, and then, over unimaginable spans of time, the black hole slowly evaporates through the emission of Hawking radiation. But this radiation is peculiar, thermal, featureless, and random. It carries no whisper, no shadow, no encoded hint of what it devoured. It's as if the universe took a match to a cherished book and then scattered the ashes to the winds without preserving a single sentence. Yet quantum mechanics screams defiance at this bleak conclusion. It insists with unwavering conviction that information cannot be destroyed, that every interaction, every entangled particle, every subtle change in state must remain reversible, traceable, and adhere to the principle of unitarity. This is not merely a suggestion, it's a cornerstone of quantum theory. So, the question that reverberates through the halls of physics is this. If a black hole can destroy information, it's not just particles that disappear, it's the very laws of physics themselves. Unitarity, the sacred rule ensuring that time's arrow can point forward without tearing the past to shreds, would be shattered. It's more than a puzzle confined to black hole physics. It's a crisis of metaphysics, shaking the very foundations of how we understand reality. Because if the universe can forget, then so can we. If information is not eternal, then identity is fragile and impermanent. If a memory, a life story, can vanish without echo or trace, then what becomes of your first love, your deepest regrets, your name whispered in the wind, your meaning. Suddenly, entropy transcends its role as a thermodynamic measure. It becomes a threat to continuity itself, a cosmic eraser that gnaws at the roots of existence. Some physicists propose a hopeful resolution, that the information isn't truly lost but encoded in the subtle correlations of Hawking radiation. The information is scrambled beyond comprehension but not erased, like a cipher waiting to be cracked, a puzzle hiding within the noise. Others suggest that black holes are not mysterious endpoints, but holograms, cosmic projection screens where the entirety of three-dimensional information is stored on a two-dimensional surface. These ideas gave rise to the holographic principle, a radical reimagining of space and information. Still others venture further, positing that wormholes, bridges through space-time, might preserve the data in parallel universes, safeguarding reality's ledger across dimensions. Conversely, some whisper of firewalls, violent energetic boundaries at the event horizon that burn any incoming information, tearing apart the smooth flow predicted by general relativity. Each theory grapples with a paradox in its own way, but all point to one fundamental truth. The universe resists the concept of true disappearance. It may hide, encrypt, scatter, or scramble information to incomprehensible degrees, but it does not forget. And yet, what if it does? What if, at the ultimate horizon, there lies not a vault of memory but a furnace of oblivion? What if the most absolute void known is not merely a lack of matter, but a profound amnesia? That the black hole doesn't just crush matter, but meaning itself? If this is so, we are forced to face a grim conclusion. Some things, once gone, are truly irrecoverable, not because of technological or intellectual limits, but because the very fabric of space-time chooses to discard them. And if the cosmos can discard information, what does that say about the permanence of thought, of love, of pain? Perhaps our entire history, every war waged, every poem penned, every quiet, stolen moment shared between two souls who never met, again, is a fragile waveform, oscillating briefly before it is swallowed into silence. But perhaps not. Perhaps the universe records everything, not for our benefit, but within us, around us, in the very quantum fields that stitch reality together. Every particle carries a memory of its origin. Every wave collapses a signature of its past possibilities. Even the void is filled with stories, whispers trapped on event horizons, waiting patiently for an interpreter to decipher their meaning. In this view, nothing is truly lost, not erased, only translated, transformed, disguised. Information, like identity, may be resilient beyond recognition, scrambled beyond meaning, yet undeniably present. Thus, the ongoing debate between information, loss and unitarity transcends physics alone. It becomes a mirror held up to our deepest hopes and fears. It's a question about whether anything we are or do truly matters in a universe where permanence is uncertain. And within this tension lies something deeply human. The yearning to believe that our experiences persist, that the universe does not merely echo, but remembers, that meaning does not dissolve into cosmic noise, that we are not mere flickers in an endless dark, but lasting impressions on the vast canvas of the cosmos. Because if even the blackest hole, the darkest abyss, cannot erase a single bit of information, then perhaps nothing is ever truly forgotten, not by the stars, not by time, and not by whatever force first shaped the cosmic rules, the nowhere paradox. Where is the edge of the expanding universe? Imagine standing not at the edge of a cliff or a memory, but at the threshold between what can be known and what might be lost forever. A line so thin it cannot be drawn, yet so vast it divides the physics of reality and the philosophy of existence. You find yourself at the mouth of a black hole, not falling in, not drifting aimlessly, but standing as a silent witness, watching the unfolding of the most haunting contradiction the universe has ever dared to present. The terrifying possibility, that information, once known, once lived, once etched irrevocably into the fabric of matter and energy, can simply vanish without a trace. Entire stars, vast libraries of light, the precise trajectories of countless particles, the very heartbeat of a traveler crossing the cosmos, all swallowed whole into an eternal silence, leaving behind a void not just of matter, but of meaning itself. This profound mystery is known as the paradox of information loss. In classical physics, the picture seems straightforward. Matter crosses the event horizon of a black hole, trapped irreversibly, and then, over unimaginable spans of time, the black hole slowly evaporates through the emission of Hawking radiation. But this radiation is peculiar, thermal, featureless, and random. It carries no whisper, no shadow, no encoded hint of what it devoured. It's as if the universe took a match to a cherished book and then scattered the ashes to the winds without preserving a single sentence. Yet quantum mechanics screams defiance at this bleak conclusion. It insists with unwavering conviction that information cannot be destroyed, that every interaction, every entangled particle, every subtle change in state must remain reversible, traceable, and adhere to the principle of unitarity. This is not merely a suggestion, it's a cornerstone of quantum theory. So the question that reverberates through the halls of physics is this: if a black hole can destroy information, it's not just particles that disappear, it's the very laws of physics themselves. Unitarity, the sacred rule ensuring that time's arrow can point forward without tearing the past to shreds, would be shattered. It's more than a puzzle confined to black hole physics. It's a crisis of metaphysics, shaking the very foundations of how we understand reality. Because if the universe can forget, then so can we. If information is not eternal, then identity is fragile and impermanent. If a memory, a life story, can vanish without echo or trace, then what becomes of your first love, your deepest regrets, your name whispered in the wind, your meaning? Suddenly, entropy transcends its role as a thermodynamic measure. It becomes a threat to continuity itself, a cosmic eraser that gnaws at the roots of existence. Some physicists propose a hopeful resolution, that the information isn't truly lost but encoded in the subtle correlations of Hawking radiation. The information is scrambled beyond comprehension but not erased, like a cipher waiting to be cracked, a puzzle hiding within the noise. Others suggest that black holes are not mysterious endpoints but holograms, cosmic projection screens where the entirety of three-dimensional information is stored on a two-dimensional surface. These ideas gave rise to the holographic principle, a radical reimagining of space and information. Still others venture further, positing that wormholes, bridges through space-time, might preserve the data in parallel universes, safeguarding reality's ledger across dimensions. Conversely, some whisper of firewalls, violent energetic boundaries at the event horizon that burn any incoming information, tearing apart the smooth flow predicted by general relativity. Each theory grapples with the paradox in its own way, but all point to one fundamental truth. The universe resists the concept of true disappearance. It may hide, encrypt, scatter, or scramble information to incomprehensible degrees, but it does not forget. And yet, what if it does? What if, at the ultimate horizon, there lies not a vault of memory, but a furnace of oblivion? What if the most absolute void known is not merely a lack of matter, but a profound amnesia? That the black hole doesn't just crush matter, but meaning itself? If this is so, we are forced to face a grim conclusion. Some things, once gone, are truly irrecoverable, not because of technological or intellectual limits, but because the very fabric of space-time chooses to discard them. And if the cosmos can discard information, what does that say about the permanence of thought, of love, of pain? Perhaps our entire history, every war waged, every poem penned, every quiet, stolen moment shared between two souls who never met, again, is a fragile waveform, oscillating briefly before it is swallowed into silence. But perhaps not. Perhaps the universe records everything, not for our benefit, but within us, around us, in the very quantum fields that stitch reality together. Every particle carries a memory of its origin. Every wave collapses a signature of its past possibilities. Even the void is filled with stories, whispers trapped on event horizons, waiting patiently for an interpreter to decipher their meaning. In this view, nothing is truly lost, not erased, only translated, transformed, disguised. Information, like identity, may be resilient beyond recognition, scrambled beyond meaning, yet undeniably present. Thus, the ongoing debate between information, loss and unitarity transcends physics alone. It becomes a mirror held up to our deepest hopes and fears. It's a question about whether anything we are or do truly matters in a universe where permanence is uncertain. And within this tension lies something deeply human, the yearning to believe that our experiences persist, that the universe does not merely echo but remembers. That meaning does not dissolve into cosmic noise, that we are not mere flickers in an endless dark, but lasting impressions on the vast canvas of the cosmos. Because if even the blackest hole, the darkest abyss, cannot erase a single bit of information, then perhaps nothing is ever truly forgotten. Not by the stars, not by time, and not by whatever force first shaped the cosmic rules. Maxwell's demon, information versus thermodynamics. Imagine standing in front of two identical rooms, filled with gas, perfectly sealed and untouched, silent and balanced, the kind of balance that only nature, in all its indifference, can maintain. Each molecule inside these rooms is moving chaotically, bouncing like unseen pinballs off invisible walls, obeying nothing but the second law of thermodynamics, entropy, the grand director of disorder. You stand there, watching this equilibrium and wondering, what if you could cheat the system? What if without adding any energy, without breaking any laws, you could somehow make one room hotter and one colder, separating fast from slow, order from chaos, without lifting a finger? That is the forbidden thought at the heart of one of physics' most mischievous ideas, a thought experiment so unsettling that it continues to haunt scientists and philosophers alike. It begins not with machinery, but with a question posed. In 1867 by James Clerk Maxwell, a man who had already reshaped our understanding of electromagnetism and light, but now he proposed something different. What if a tiny, invisible being, a demon, he called it playfully, sat at the boundary between the two rooms, watching every particle pass? What if this demon could open and close a microscopic door with perfect timing, letting only fast-moving particles through to one side and slow-moving ones to the other? Over time, one room would heat up, the other would cool down. Energy would separate itself spontaneously. Entropy would be reversed. The second law would be broken, and in that moment, everything we know about heat, randomness, and the direction of time would collapse. But how could such a little thought, a hypothetical imp with perfect knowledge, pose such a threat to the pillars of thermodynamics? The answer lies not in mechanics, but in information. Maxwell's demon doesn't use force. It doesn't move particles. It doesn't inject energy. All it does is observe, decide, and act. And this action, this simple act of knowing, is what breaks the universe's rules. Or so it seems. For decades, physicists debated the paradox. Some dismissed it as philosophical mischief. Others were shaken. How could something as incorporeal as observation bend the laws of physics? The second law of thermodynamics is not a suggestion. It is one of the most robust principles in all of science. It says that entropy, the measure of disorder, must always increase in a closed system. Ice melts, buildings crumble, stars burn out, hot coffee cools. The universe moves from order to chaos, not the other way around. So why did Maxwell's demon suggest a way around this iron law? Here's where the true beauty of the paradox emerges. The demon doesn't just cheat physics. It exposes a deeper truth hidden beneath it, that information is not free. In the 20th century, as computers began to evolve and information theory emerged, thinkers like Leo Szilard and later Rolf Landauer proposed a stunning resolution. Yes, the demon can sort particles. Yes, it can reduce entropy, but only if we ignore what the demon must pay in return. You see, every time the demon measures a particle, stores that information, and uses it to make a decision, it builds a mental ledger, a record of microscopic choices. And at some point, to make room for more observations, the demon must erase that information. And erasing information, it turns out, is not free. Landauer's principle tells us that erasing even a single bit of information has a minimum thermodynamic cost. That cost is paid in heat. It's entropy by another name. The paradox isn't solved by force. It's solved by realizing that thinking has a price. Knowledge is physical. Decisions are thermodynamic events. And in the end, the total entropy still increases. The second law survives, not because the demon is caught cheating, but because reality quietly charges interest on every act of cognition. Maxwell's demon doesn't break the rules. It simply reveals that the rules are deeper than we thought. But let's step back and see what this really means. Not for particles, but for people, for you. Because Maxwell's demon is not just a quirky thought experiment in a dusty textbook. It is a mirror held up to the mind. Think about how many times you, as a conscious observer, act like the demon. You sift through chaos, looking for patterns. You separate truth from noise, fast thoughts from slow ones. You make decisions. What to remember, what to forget, what to let through the door. And with every act of attention, every observation, every conscious choice, you burn energy. Your brain is an organ of thermodynamic discrimination. Every bit of memory, every suppressed fear, every learned name, it all has a cost. Forgetting is expensive. Awareness is thermodynamically real. In this way, the demon isn't fiction. It's alive in every neuron. Every decision you make incurs entropy somewhere else. In your body, in your environment, in the future. And, perhaps most hauntingly, in the trajectory of your own life. This idea stretches even further when we ask, what is the cost of knowing the truth? Because sometimes, knowledge brings clarity. Other times, it brings sorrow. To see something clearly is to let go of comforting illusions. And in that moment, when the truth passes through your mental gate, something else must be pushed aside. This too is entropy. This too is irreversible. The arrow of time, painted in thought. Just like Maxwell's demon must erase its memory. To make space for new choices, we too must shed our past selves to move forward. Learning requires forgetting. Growth demands sacrifice. And even in the realm of pure ideas, thermodynamics still whispers its law. Nothing comes for free. The implications ripple into philosophy. Is free will just an illusion of choices weighed by hidden thermodynamic costs? Are consciousness and thought merely byproducts of energy and entropy dancing in tight patterns? If so, then who is the real demon? Maxwell's thought construct, or the self-reflective mind that dares to question its own origins? Is knowledge empowering, or does it come with a toll we're too eager to ignore? The paradox refuses to stay still. It wriggles into debates about AI, where systems must learn and forget at scale. It sneaks into conversations about data, surveillance, privacy. In a world overflowing with information, who pays the thermodynamic bill for every tweet, every search, every stored byte? Somewhere, something is warming up because we chose to remember. The internet is a global-scale demon sorting signal from noise, shaping reality with algorithms that observe, measure, act, and erase. And now, as you sit with this idea, perhaps you feel it too, that strange gravity of thought, pulling at the edge of comprehension. Because the Maxwell's demon paradox is not just about the limits of physical law, it's about the fragility of perception, about the hidden price tags on awareness, about how even the act of watching the universe unfold is a participation in its irreversible unfolding. In the end, the second law of thermodynamics doesn't fail. It deepens. And Maxwell's demon, far from being a trickster, becomes a prophet, showing us that knowledge, choice, and memory are not just abstract concepts, but physical forces woven into the fabric of reality. There is no free insight. There is no frictionless decision. Even the quietest thought is a spark in the machinery of the cosmos. And the demon, it turns out, is not at the door between two gas chambers. It's within us, at the threshold of every moment, asking, will you open the gate? And if you do, what will it cost you? The Boltzmann brain paradox. Are you just a random fluctuation? Imagine just for a moment that everything surrounding you, this screen glowing softly in the dim light, the warmth of sunlight touching your skin, the subtle pressure of gravity, holding you grounded, the flood of your memories that form your sense of self, your very name whispered through time, the laughter and tears of your childhood, the people you have loved deeply and lost painfully, the fears you have faced and conquered, the mistakes etched into your history, the entire saga of Earth itself, the rise and fall of empires, the scientific laws you've learned, the truths you hold dear. All of it, absolutely all of it, might not be the product of billions of years of cosmic evolution, ordered entropy, and natural law. Instead, it might be the result of one singular, spontaneous, utterly meaningless, and random fluctuation in an immense sea of chaos, a momentary blip in the vast void where entropy hiccuped ever so perfectly to create not a vast universe, but just you, your brain, floating alone and disembodied in the cold, infinite vacuum of space, complete with fabricated memories, a fabricated sense of time, and a compelling illusion of continuity. This is the profoundly unsettling concept known as the Boltzmann brain paradox, a thought experiment that transcends mere speculation. It shakes the very foundations of how we define existence, reality, and consciousness itself. The paradox traces back to the 19th century, and the Austrian physicist Ludwig Boltzmann, who wrestled with reconciling the relentless increase of thermodynamic entropy with the undeniable order we observe in the universe. Boltzmann reasoned that if the universe naturally trends toward disorder, then ordered structures, including intelligent observers like us, must be rare exceptions. Yet if the laws of statistical mechanics hold true, then over infinite time in an eternally fluctuating, chaotic environment, even the most improbable configurations must eventually arise. Among these improbable configurations is the notion of a solitary brain, spontaneously and randomly assembled, a single, conscious entity with no body, no external world, no history, experiencing a brief flash of self-awareness and perception, fully believing it is alive, thinking it had a past, perceiving a detailed but false reality. This brain does not arise through biological evolution within a structured universe. It simply pops into existence momentarily before dissolving back into the sea of thermodynamic equilibrium from whence it came. From a purely probabilistic standpoint, this leads to a deeply disquieting conclusion. Given infinite time and space, it is exponentially more likely for a single brain to spontaneously fluctuate into existence than for an entire low-entropy universe, like the one we inhabit, to arise naturally. If you accept that the cosmos operates under the relentless march of entropy across infinite spans, then logically, it's more probable that you are a Boltzmann brain, a fleeting, accidental mind floating alone in the void, rather than a product of eons of cosmic evolution on Earth. Yet here you are. You feel real. You feel grounded. You remember yesterday. You anticipate tomorrow. You see the stars and touch the ground beneath your feet. You hunger. You love. You ache. These sensations do not feel like the programmed flickerings of a random, ephemeral neural cloud. But then again, would a Boltzmann brain feel any different? If it is born complete with all your memories, perceptions, and neural patterns fabricated, though they may be, how could you ever distinguish reality from illusion? How could you discern true experience from the simulation of experience? This paradox slices deeply, not only into the domain of physics, but into the very essence of consciousness and philosophy. It forces us to confront the age-old question: what does it mean to be real? Is reality defined by continuous existence, by causal chains stretching backward in time, by shared experience and collective memory? Or can it be perfectly simulated, artificially generated, and sustained entirely through the random fluctuations of thermodynamic chance? If a structure randomly arising from chaos mimics reality flawlessly, is it any less real? And if so, how can anyone be certain they are not living within an elaborate statistical lie, a fleeting ripple in the vast cosmic sea of chance? This unsettling idea haunts not only cosmologists, but also philosophers and thinkers grappling with the nature of existence, especially as modern cosmological models propose universes that are eternal, cyclic, or infinitely expanding. In these frameworks, the longer time stretches on, the more inevitable the appearance of rare, high-entropy fluctuations. Yet among these fluctuations, entire universes like ours are astronomically rarer than isolated, disembodied brains. We are thus plunged into a spiral of doubt and existential uncertainty. Could this entire observable cosmos, the billions of galaxies, the cosmic microwave background radiation, the precisely fine-tuned physical constants, be nothing more than a carefully orchestrated illusion? A grand stage set to convince a lone, ephemeral brain that it is part of a coherent, continuous reality, that it was not simply born moments ago with false memories and a fabricated sense of time? But this thought is not mere nihilistic fantasy. It poses a genuine and serious challenge to the frameworks underlying modern cosmology. The Boltzmann brain problem has emerged as a crucial test for theoretical models of the universe. If a theory predicts that Boltzmann brains vastly outnumber normal, evolved observers, then the theory undermines its own credibility, because it suggests that most individuals endorsing it are deluded illusions themselves. It becomes a philosophical Ouroboros, a snake consuming its own tail, a loop that defies stable self-consistency. Yet beyond cosmology, this paradox invites us to examine the delicate fragility of our assumptions about knowledge, identity, and reality. In a universe governed by probabilistic laws, where entropy reigns supreme and anything not explicitly forbidden must eventually occur, certainty becomes a rare and precious commodity. The Boltzmann brain represents the ultimate nightmare of solipsism. Not that you are the only conscious being, but that your entire consciousness may be a brief glitch in the cosmic darkness, a momentary ripple in an indifferent void. And yet, amidst the dread, the paradox offers a strangely beautiful glimmer of hope, that we exist not because it is easy or probable, but precisely because it is extraordinarily improbable. That meaning arises not from statistical likelihood, but from the stubborn persistence of structure, connection, and awareness in a universe inherently predisposed to decay and disorder. Perhaps what truly matters is not whether we are objectively real within the cold machinery of entropy, but that we think, feel, and love as if we are. Because in the end, perhaps the universe itself does not care whether we were born from the stars or from random noise. It only asks one question: what will you do with this moment, this fleeting awareness, this fragile spark of ordered thought, before the cosmic wave inevitably collapses back into silence? The ship of Theseus. Is identity in the parts or the pattern? Imagine standing before a ship docked quietly in a serene harbor, its wooden planks gleaming softly under the golden kiss of sunrise, sails neatly furled like resting wings, and ropes coiled carefully, bearing the memory of countless voyages across vast seas and time itself. This is the ship of Theseus, a vessel that carries not just the wear of the ocean, but the weight of an ancient philosophical puzzle nested deep within its hull. If every single piece of this ship, every plank, every mast, every nail, were replaced, one by one until not a single original part remained, would it still be the same ship? Would it retain its name, its essence, its identity? Or would it become something else entirely, an imposter sailing beneath a familiar flag? This question, seemingly simple and quaint on the surface, slices through the very foundations of how we understand continuity, consciousness, memory, and the self. At first glance, the ship of Theseus might appear to be just a metaphor, a clever philosophical parlor trick meant to entertain and confuse. But as you dwell on it, a profound realization dawns. You are the ship. Your body, your mind, your relationships, your beliefs, they are all in a constant state of flux. The cells within your body replace themselves regularly. Your neurons forge new connections and shed old ones. Your memories fade or shift in clarity. Your opinions evolve as you encounter new ideas. And yet, despite this perpetual change, you insist that you remain the same person who laughed as a child, cried as a teenager, and pondered just last week whether you were on the right path. But how can that be? When none of the physical parts are the same, what anchors the whole? What is the you that endures? Is the you of today truly the same you from years ago? Or are you but a ghost, an ever-shifting narrative reconstructed through habit, memory, and illusion? Consider, too, the paradoxical thought of what might happen if, somewhere in a dusty shipyard, someone gathered all the discarded parts of the original ship of Theseus and painstakingly reassembled them piece by piece. Would this be the true ship, the original, authentic vessel? Or would it be a replica, a hollow facsimile composed of familiar parts, but lacking the intangible essence? This haunting question doesn't merely whisper from the halls of ancient philosophy. It thunders through modern science, technology, and the very concept of identity. Neuroscience reveals that the brain is a dynamic, ever-changing organ. Neurons die, new pathways form, synapses strengthen and weaken in an endless dance of plasticity. Your brain is not a fixed machine. It is a vibrant sea of shifting patterns, sculpted by experience and time. Biology tells us that your body today is fundamentally different from the one you had a decade ago. Its cells turn over, molecules renew, and even the community of microorganisms within you, the gut microbiome, evolves constantly like leaves in the autumn wind. In digital realms, your online persona is curated, updated, and transformed with every post, comment, and interaction, becoming a version of yourself that may outlive your physical presence. So, what is it that holds the self together? Is it a continuity of experience, a thread of memory that weaves disparate moments into a coherent narrative, a pattern that the mind recognizes in the mirror each morning? Or is it simply a convenient fiction, a psychological anchor needed to prevent us from dissolving into existential ambiguity? The ship of Theseus paradox does not stop at ships or brains. It extends into every facet of human life. It is about lovers who fall out of love, questioning whether the person beside them is still the same soul they once adored. It is about friendships stretched and worn by time, wondering if the bond remains or has been replaced by something new. It is about cities rebuilt from ruins after wars, their stones the same, but their spirit changed. It is about artists who reinvent themselves so frequently that they wonder whether they have betrayed their original vision or simply evolved into something greater. It is about grief, about standing over a grave, whispering into the vast sky, and questioning whether the essence of the one lost still lingers in the world. Somewhere, somehow. It is about software updated repeatedly until no original line of code remains, yet we continue to call it by the same name. It is about language, culture, faith, and family, all constantly evolving, yet retaining names that root us to our histories, even as their meanings shift beneath us. It's about the human need to hold on, to justify permanence, to claim stability in a world defined by constant erosion and change. And within this tension, we find ourselves adrift in a vast sea of paradox, desperately clutching to continuity, even while every atom whispers the undeniable truth of transformation. So, what then is identity? Perhaps it is not found in the individual parts but in the pattern they form, the emergent whole beyond the sum of its pieces. Perhaps it is not the material substance but the motion, the rhythm that courses through the fabric of being. Consider a song. It remains recognizable even if the instruments change, as long as the melody persists through time. Perhaps you are not the flesh and blood, the breath and bone that currently comprise you, but the rhythm to which these elements dance, the harmony that binds them together. Yet even this metaphor raises questions. If the melody itself changes over time, when does it become a new song? Or are all songs, like all people, forever in a state of becoming? Perhaps identity is more akin to fire. No single molecule defines the flame, yet the flame exists, consistent in form, flickering with presence and life. Or like a river, ever flowing, never composed of the same water twice, yet still known as the Mississippi or the Nile, a symbol of Heraclitus' timeless insight that you cannot step into the same river twice. And so, we return to the harbor, where the ship of Theseus waits patiently, unchanged in name but transformed in form. You step aboard. The deck creaks softly beneath your feet, old wood rendered new by belief. You reach out and touch the rail, worn smooth not by centuries alone, but by the collective faith of all those who have sailed before you. And you set sail into the future, not because the ship remains identical, but because you believe it to be. Perhaps that belief, the continuity of meaning and memory, is all that identity ever truly was. The choice to remember, to connect, to name the shifting sands and call them home. The brain in a vat problem. Could all this be a lie? Imagine for a moment that your entire reality, the warmth of sunlight on your skin, the sound of your voice reverberating in a quiet room, the memory of your first heartbreak, the smell of rain on pavement, your body as it stretches with fatigue or trembles with fear, is nothing more than an exquisitely crafted illusion fed into your consciousness by a machine. Picture a brain, your brain, floating in a translucent vat of life-sustaining fluid, its every neural impulse meticulously simulated by a supercomputer beyond comprehension, feeding it a consistent, coherent, and believable reality. You are not in a room, not on Earth, not even in a universe, but suspended in an artificial dream, constructed not by gods or ghosts, but by code. This is the unsettling hypothesis known as the brain in a vat, a modern philosophical descendant of Descartes' evil demon thought experiment and perhaps the blueprint for every sci-fi dystopia ever imagined. At first glance, it seems absurd, science fiction at best, paranoia at worst. But as you begin to pull the thread, the fabric of certainty unravels, and you find yourself confronting the deepest epistemological question. How do you know that anything you experience is real? Every sensory input you rely upon, vision, sound, touch, taste, smell, is a product of electrical signals interpreted by your brain. In principle, those signals could be faked. If so, then your body could be a lie. Your friends, your childhood, your memories, your emotions, your accomplishments, all could be simulated. You could be a brain floating in isolation, tricked into believing in a life you never lived. And here lies the terrifying power of the thought experiment. You cannot disprove it. There is no logical contradiction in the scenario, no empirical method to falsify it, because every observation you make is filtered through the very system under suspicion. This epistemic trap forces us to wrestle with what it means to know something. If every piece of evidence you rely on is part of the simulation, then evidence itself loses its grounding. The brain in a vat problem draws a brutal line between belief and truth, showing how easily one can exist without the other. Philosophically, it devastates naive realism, the idea that the world is exactly as we perceive it. It echoes Plato's allegory of the cave, where prisoners mistake shadows for reality, having never seen the fire or the forms that cast those shadows. In this modern retelling, the shadows are photons converted into voltage spikes, and the cave is a vat somewhere in a laboratory you'll never see. But beyond the metaphysics, the thought experiment gnaws at the foundation of identity. Who are you, if not the body you think you inhabit? If your sense of self can be simulated, is there any essence to you that is irreducibly real? Are you your brain, or are you the story your brain believes? The problem also tangles with the nature of consciousness. Can a simulated environment produce genuine subjective experience? Or is awareness dependent on an underlying physical reality? Some argue that if you feel, think, and choose within the simulation, then your consciousness is as real as any other. But others counter that. A life built on lies, even if indistinguishable from truth, is not life at all. Merely a performance without audience or meaning. The philosophical terror sharpens when this merges with modern science. In neuroscience, we already accept that our brains construct our reality. The brain does not passively receive the world. It actively predicts, fills in gaps, and edits memories. Quantum physics adds further tension. Some interpretations suggest reality does not even solidify until it is observed. Combine this with virtual reality, brain-computer interfaces, artificial intelligence, and our growing ability to simulate environments. And suddenly, the brain in a vat feels less like a fiction and more like a forecast. The simulation hypothesis, championed by thinkers like Nick Bostrom, posits that if technologically advanced civilizations create simulations indistinguishable from base reality, then it is statistically likely that we are inside one of them. In this view, your vat is not glass and wires, but algorithms and purposefully generated noise. But let's move past the fear. What if it's true? What if everything around you is synthetic? The initial horror gives way to a second question. Does it matter? If the world feels real, if your pain is real, your love real, your decisions and regrets and hopes real, does the source of those experiences negate their value? Is the beauty of a sunset invalidated if it's rendered in code? Does kindness lose meaning if given within a simulation? The answer may depend on whether we prioritize truth or meaning. Some will argue that even the richest life, if false, is still a betrayal. Others will say that experience itself, joy, love, growth, is the only currency that matters, regardless of origin. The thought experiment then shifts from epistemology to ethics, from what is real to what is right. If you are in a vat, does the entity running your simulation owe you anything? Are they a god, a torturer, a curious student in a science class? And would you, if given the option, choose to escape, knowing that the outside might be worse, emptier, more painful? Or would you choose the beautiful lie? The brain in a vat also invites self-examination. Even if you are not literally in a vat, how much of your current reality is mediated, filtered, constructed? Your identity is shaped by culture, language, environment, social structures, biology. Your sense of free will may be an elaborate narrative stitched together after decisions are made unconsciously. Your worldview is sculpted by algorithms, preferences, and cognitive biases. In a sense, we are all already in vats of ideology, of culture, of perception. The metaphor expands. Perhaps the true threat is not an external simulation, but an internal one. A mind trapped in loops of self-deception, echo chambers of thought, believing it sees clearly when it is blind. Then, the vat becomes not a machine, but a mirror, and the escape hatch is not physical, but philosophical. Through introspection, critical thinking, compassion, and courage, we may pierce the simulation of self and glimpse something more authentic. Yet even this is not guaranteed. The brain in a vat forces humility. It reminds us that our access to truth is fragile, that our minds are not neutral windows, but distorted lenses. It invites awe at the mystery of consciousness and the precarious miracle of experience. And it reminds us that what we call reality is not merely what is outside us, but also what arises within. In conclusion, the brain in a vat is not just a thought experiment. It is a mirror held up to every assumption we make about existence, knowledge, perception, and value. It teaches us to question without falling into despair, to seek without, demanding certainty, and to live meaningfully even in the absence of guarantees. Whether or not you are truly in a vat, one fact remains. Your thoughts are happening now. You are experiencing. That flicker of awareness, even if everything else is a lie, might be the most real thing there is. And perhaps, just perhaps, that is enough. The time crystal paradox, objects that repeat without energy use. Imagine a metronome that never winds down, a heartbeat that pulses forever without consuming a single drop of energy, a swing that arcs back and forth through eternity without ever slowing, tiring, or aging, not because it is being pushed, nor because it's plugged into some hidden source of fuel, but because it exists in defiance of one of the most sacred laws of physics, the second law of thermodynamics. That law, our compass for all things, decaying, dissipating, and ending, says that systems naturally tend toward disorder. Movement slows, energy spreads, chaos wins. But now, enter a realm so bizarre it seems to have been stolen from the margins of a sci-fi manuscript. The realm of time crystals. Structures not made of shimmering minerals, but of moments, patterns in time that repeat without any energy, input. If a regular crystal is spatial symmetry frozen in 3 dimensions, a snowflake or a diamond where atoms repeat in space, then a time crystal is symmetry frozen across the 4th dimension, time itself, dancing in cycles, not because someone is pressing play, but because reality itself is looping. These aren't theoretical baubles, figments of speculative imagination. Time crystals have been built, first theorized by Nobel laureate Frank Wilczek in 2012, then brought to life in laboratories using quantum systems cooled near absolute zero, where normal intuition collapses and particles follow the strange arithmetic of superposition and entanglement. At this temperature, atoms don't behave like marbles. They behave like waves, smeared across possibilities. And it is here, in this spectral chill, that scientists coaxed particles into patterns not only across space, but across time. In other words, the system's ground state, its most stable, lowest energy configuration, was not stillness, as you'd expect, but motion. This is where the paradox opens like a trapdoor beneath our understanding. Because motion, classically, implies energy consumption. A pendulum swings, but it slows. A clock ticks, but it needs winding. A planet orbits, but eventually friction bites. Yet time crystals pulse, without loss, without input, defying the rulebook of thermodynamics, or so it seems. But how is this possible? Are they violating the second law? Are we witnessing a loophole in the universe's machinery? To answer, we must shift from the macro world of apples and arrows and entropy to the quantum world, where energy landscapes are weirdly constructed and the classical definitions start to blur. In quantum mechanics, systems can oscillate between states without absorbing energy, provided they are isolated and driven in precise rhythms, a property called Fluctuation dynamics. In this framework, time crystals aren't using energy to move. They are locked in an internal beat, like a record with a skipping groove that endlessly replays a fragment of melody, not because it is powered, but because that repetition is the most stable state it can exist in. Still, it leaves us in an ontological fog. How can something do without spending? How can time pass for a system that doesn't pay entropy's toll? This question touches the root of what we mean by time. We usually think of time as a river, forward-flowing, irreversible, sweeping us from past to future. But time crystals suggest another metaphor, a wheel. Not time as a line, but as a loop, where return is possible, where the future folds into the past. They make us ask if time, like space, might be granular and geometric, capable of patterns and repetitions at its most fundamental scale. But here's where the philosophy creeps in like mist under a locked door. If an object can exhibit periodic motion in time without consuming energy, then perhaps time itself is not the background upon which the universe plays out, but a physical quantity, a substance that can crystallize, repeat, resist entropy. Perhaps the arrow of time is not intrinsic but emergent, a feature of messy systems like our brains and thermodynamic chaos. Not a law of nature, but a property of perception. Time crystals whisper that what we feel as the relentless march of time might just be a local illusion, a projection of a deeper reality where repetition, not progression, is the default. And this has profound implications in a world where time can be symmetrical, where systems can oscillate eternally in their lowest energy state. Could memory, history, and experience themselves be structures that repeat? Could consciousness, that elusive, flickering awareness we each possess, be a time-bound crystal of thought, repeating micro-patterns that we mistake for a continuous flow? The implications also touch cosmology. Our universe, we believe, began with a Big Bang, a singularity of low entropy, and it has been winding down ever since. But what if, at its core, the cosmos behaves like a time crystal? Could the entire universe be a vast, self-repeating system, cycling through the same configurations? Not because it needs to, but because that's its lowest energy state. It's speculative, yes, but not dismissed. Some theories of eternal recurrence and cyclic universes echo this idea, that the universe expands and contracts in endless loops, time folding into itself like a cosmic breath. If time can repeat, and if repetition doesn't require energy, then perhaps beginnings and ends are illusions. And all that exists truly is rhythm. But before we drift too far into metaphysics, let us return to the laboratory, to the isolated ions in a trap, the laser pulses calibrated with quantum precision, the fragile dance of particles oscillating on the edge of comprehension. Time crystals are not magical. They are quantum systems under specific constraints. They don't violate laws. They expose their subtlety. The second law of thermodynamics still holds in the universe at large. Time crystals don't cancel entropy. They sidestep it by existing outside the kinds of systems the law governs. They are loopholes, not contradictions, exceptions that prove the rule's limits. But like all paradoxes in science, they're real. Value lies not in breaking the laws, but in expanding our understanding of them. Time crystals open a door into the fabric of time itself, a door we didn't know existed. And once that door is open, we can't help but peer through it and ask, what else lies behind the veil of what we call reality? In conclusion, the time crystal paradox doesn't just challenge physics, it challenges perception. It forces us to reevaluate our assumptions about motion, time, and energy. It invites us to imagine a reality where repetition is stability, where stillness is movement, and where the future is not a destination, but a resonance. In this new vision, the ticking of a clock is not a countdown to decay, but a vibration of possibility, a pulse that echoes without loss. Time crystals remind us that the universe is not obligated to conform to our metaphors. It is stranger, deeper, and more rhythmic than we ever suspected. And in their eternal, energy-free beat, they might just be humming the forgotten melody of time itself, the quantum Cheshire cat, a particle's properties without the particle. Imagine walking through a dark forest when suddenly, just ahead, you spot a smile. Not a face, not a body, but a disembodied grin, suspended in the air, shimmering faintly, in the moonlight, as though reality itself has glitched and left behind a piece of expression divorced from the being who wore it. This surreal image, straight from Lewis Carroll's Alice in Wonderland, isn't just literary whimsy anymore. It's a metaphor that physics has borrowed to describe something far stranger than fantasy. Something that's not just a paradox, but a revelation of the hidden fabric of reality. In the quantum world, there exists an experiment where a particle, say a neutron, appears to go one way, while one of its defining properties, such as its magnetic moment, goes another, as if the particle's identity can be decoupled from its attributes, as if the smile can walk without the cat. Welcome to the mind-bending territory of the quantum Cheshire cat. a phenomenon that doesn't just challenge what we know, but how we know it. In classical physics, an object is inseparable from its properties. A red apple is red. Its color is part of what makes it it. But quantum mechanics scoffs at such intuition. In an experiment first proposed in 2013 and later realized using neutron interferometry, physicists demonstrated that under specific measurement setups, weak measurements that don't collapse the wave function, they could infer the presence of the neutron's magnetic moment in one part of the interferometer and the neutron itself in another. The particle and one of its essential qualities appeared to be in different places at the same time. It's not that the property was lost or transferred, it was detected where the particle wasn't. This should be impossible, and yet it happened. But how? To answer, we must revisit the very structure of quantum mechanics, a framework built not on solid objects moving through space, but on probabilities, amplitudes, and entanglements. In quantum physics, particles don't have positions or velocities until measured. They exist in superpositions, overlapping possibilities that don't become definite until an observation is made. But even observation is layered. Strong measurements collapse the state, forcing the system into a definite outcome. Weak measurements, by contrast, gently nudge the system, allowing information to be extracted without fully collapsing the wave function. And it is here, in this strange middle ground between knowing and not knowing, that the quantum Cheshire cat emerges. The cat, the particle, and its grin, the property, can be inferred to travel along different paths because the mathematics of quantum measurement allows them to behave as if they are not bound together. It is a metaphysical divorce between essence and identity. This leads us into deep philosophical territory. What is an object if it can exist without its attributes? What is identity if it is no longer a sum of parts, but a cloud of shifting probabilities? The quantum Cheshire cat blurs the lines between what a thing is and what a thing does. And this blurring has consequences, not just for physics, but for our entire metaphysical framework. Consider the implications. If a particle's property can exist apart from the particle, what does that say about the self? Could consciousness be disassembled in the same way? Awareness traveling down one path, memory another. Could emotions, intentions, or identity itself be smeared across experiences without being tied to a core? Are we not single entities, but bundles of attributes, held loosely together by observation? Perhaps the self is not an indivisible monolith, but a shifting interference pattern, a quantum hologram of thought and presence. The quantum world is not made of objects with properties. It is made of relationships, entanglements, information, flows. The particle is not a marble, but a story, a set of correlations between measurements. The smile is not a feature of the cat. It is a consequence of how you look at the cat. This is the new ontology that quantum mechanics forces upon us. The quantum Cheshire cat is not a bug in the system. It is a glimpse into the operating code beneath reality. But it's not just metaphysical, it's operational. In quantum computing, understanding how attributes can be decoupled from carriers could have practical applications in error correction and information routing. In quantum cryptography, it hints at new ways to encode and protect information. And in quantum foundations, it shows us that the very idea of where and what may not be as tightly coupled as we once thought. Yet the paradox is more than scientific curiosity. It's a mirror. Because when we stare at the quantum Cheshire cat, we are also staring at ourselves. Just as the neutron and its property go separate ways, how often do we separate our own qualities from our actions? We wear smiles while hiding sadness. We carry anger without movement. We exist in rooms while our minds wander elsewhere. In a sense, we are all quantum Cheshire cats, leaving traces of ourselves in conversations we've left behind, feeling disconnected from the emotions we display, fragmented between identity and experience. The quantum realm has always been a metaphor factory, spawning insights into free will, determinism, consciousness, and the limits of knowledge. But this paradox goes deeper. It says the world itself may not be made of things, but of observations. What you see depends on how you look. What exists may be inseparable from the act of knowing it. This is not solipsism, but participatory realism. The idea that reality is not passively there, waiting to be discovered, but co-created through interaction. The quantum Cheshire cat shows us that even properties, those supposedly inherent aspects of things, are not safe from this strange participatory nature. They too can wander, be reshaped, be elsewhere. In this way, quantum physics becomes not just a science, but a philosophy, a way of seeing that forces humility. We are not observers of a fixed universe. We are entangled participants in a dance of appearances, correlations, and probabilities. And the most unsettling part: it works. The math holds. The predictions match the data. The neutron really does act as if it's on one path while its magnetic moment takes another. What once seemed like madness becomes method. In conclusion, the quantum Cheshire cat is not merely a curiosity tucked away in the corners of particle physics. It is a profound statement about the nature of being. It invites us to consider that identity is not singular, that reality is not composed of building blocks, but of waves, symmetries, and ephemeral traces. It shows us that the universe is not a stage with actors and props, but a script in which lines, scenes, and meanings rearrange depending on who reads them and how. In a world where a grin can outlast the cat, where properties can roam without their hosts, where presence is a question and absence is a clue, we are left not with answers, but with awe. And perhaps that is the point. Not to resolve the paradox, but to live within it, curiously, cautiously, and always questioning what it means to be real. The fine-tuning paradox. Why does the universe seem perfect for life? Imagine sitting in a room where every dial on a control panel determines the shape of the universe. One knob sets the strength of gravity, another the charge of the electron, another the rate of cosmic expansion, the density of dark matter, the curvature of space, the ratio of carbon to oxygen, the speed of light, the mass of quarks. And each dial is tuned not just within broad margins, but to razor-thin tolerances so precise that a slight twist in any direction would render the cosmos barren, chaotic, or incapable of sustaining the most basic building blocks of life. Now imagine that you didn't set these dials. They were already there, perfectly adjusted. The room was already humming. You merely woke up in it. This is the haunting elegance of the fine-tuning paradox. The observation that the fundamental constants of nature appear to be calibrated with uncanny precision to allow life, complexity, and consciousness to exist at all. The paradox begins, not with speculation, but with measurement. Physicists have long known that if the gravitational constant were slightly stronger, stars would burn too fast and collapse too quickly. If weaker, no stars would ignite. If the electromagnetic force were different by a fraction of a percent, chemistry would break. If the strong nuclear force were altered ever so slightly, atomic nuclei wouldn't hold together. If the cosmological constant, the mysterious repulsive force accelerating the universe's expansion, were even slightly larger, matter would be flung apart before galaxies could form. The list goes on. Life as we know it sits precariously on the tip of a pin, balanced in an abyss of possible values. And this balance seems improbable, not just statistically, but philosophically. Why should the universe be so just right? Why should the laws of nature not only permit, but in some ways encourage, the emergence of stars, planets, organic molecules, sentient minds? This is not to say the universe is teeming with life. It may be vastly empty, but rather that the physical conditions needed for life are embedded into the very scaffolding of reality. The deeper we look, the more finely tuned the universe appears. And this leads to an uncomfortable question. Why? There are several responses to this. The first is necessity. the idea that the laws of nature are what they are and could not be otherwise. Perhaps there's only one internally consistent way to build a universe, and we happen to live in it. But this explanation rings hollow for many physicists and philosophers because it feels like a dodge. It doesn't explain why this consistency allows life, rather than, say, a sterile expanse of inert particles or endless radiation. The second explanation is chance, that we just got lucky. But invoking chance to explain a situation with so many delicate variables begins to stretch plausibility. If you won the lottery once, it's luck. If you win it every day for a year, suspicion grows. The third explanation is perhaps the most controversial: design, that the universe was created or programmed in such a way as to allow life, either by a deity, an intelligence, or some cosmic agency. But this raises more questions than it answers. Who or what did the designing? Where did they come from? Are we in a simulation? Is the designer part of a greater framework? And why would the universe be so enormous and ancient, with life appearing in only the tiniest corners? If design was the goal, then comes the fourth and most intriguing explanation: the multiverse. If there are countless universes, each with different physical constants, then most of them would be lifeless. But in a few, perhaps only a minuscule fraction, the dials would land on the right settings by random variation. We, as observers, would naturally find ourselves in one of these rare, life-permitting universes, because only there could we exist to ask the question. This is the anthropic principle, the idea that the universe must appear fine-tuned to us, because we're only capable of observing a universe that allows our existence. But the multiverse hypothesis, while elegant, is untestable. Other universes, if they exist, are causally disconnected from ours. We can't reach them, measure them, or verify them. So while the multiverse dissolves the fine-tuning problem statistically, it replaces it with metaphysical uncertainty. Are we prepared to accept an infinite number of unseen realities just to explain the precision of this one? Some physicists have tried to model the multiverse using string theory landscapes or inflationary cosmology, but these frameworks remain speculative. Still, the fine-tuning problem remains, unsolved, unyielding, and profound. But perhaps the problem is not with the universe, but with us. Perhaps we are asking the question backwards. Instead of wondering why the universe is fine-tuned for life, we might ask, is life fine-tuned for the universe? Did the conditions of this cosmos shape life so precisely that only the configurations allowed by these constants could ever be considered life? In this view, life is not a favored outcome, but a fragile echo of cosmic conditions, a ripple on the surface of physical law, no more mysterious than frost forming on glass under the right humidity. But this too carries implications. It suggests that life is not inevitable, but contingent, not the goal, but the accident. And if so, then consciousness, meaning, and everything we value may be footnotes in a vast, indifferent expanse. Yet here we are, thinking, dreaming, questioning. And that fact, regardless of its origin, cannot be ignored. The fine-tuning paradox isn't just a physics problem, it's an existential one. It touches theology, cosmology, metaphysics, and epistemology. It asks not just what kind of universe we inhabit, but what kind of minds we are to notice its subtleties. Are we hallucinating order in chaos? Or has the universe, through blind mechanics or hidden purpose, conspired to become aware of itself through us? Is the observer a coincidence or a necessity? Some philosophers argue that the fine-tuning paradox is a misframing, that our sample size is one and we simply don't know what universes without life would look like. Others argue that the paradox reveals a gap in our understanding, that we are missing some deeper principle, perhaps a unifying theory that would show why these constants aren't random at all. Maybe the universe is not fine-tuned for life. Maybe life is the inevitable expression of a deeper symmetry, one we have yet to uncover. Maybe the dials aren't arbitrary, but locked together by a hidden logic. One that reveals life not as an accident, but as a resonance. This leads to a more spiritual, though not necessarily religious, interpretation. That consciousness is not a byproduct, but a fundamental aspect of reality. That the universe is not merely matter, but also mind. That the fine-tuning we observe is not an illusion, nor a miracle, but a clue. A crack in the surface of the material, revealing a deeper, intentional structure underneath. But intention need not imply a God. It could imply process, a law of emergence, a loop of self-reflective complexity where the universe births minds, and those minds, in turn, reconstruct the universe. A cosmic Ouroboros, devouring its tail, creating itself. In conclusion, the fine-tuning paradox is not merely a scientific oddity, it is an invitation to wonder, to question, to look deeper. It reminds us that the universe could have been different, and yet here we are, breathing, feeling, doubting, loving. The dials could have spun into meaninglessness. Instead, they whispered possibility. Whether this was luck, necessity, design, or something stranger, we may never know. But in asking the question, in noticing the perfection and daring to doubt it, we become part of the paradox itself, observers within a system that seems made to be observed, minds shaped by laws that almost seem to anticipate them. The universe may not owe us answers, but the fact that we're capable of asking the questions, that perhaps is the most finely tuned mystery of all. The double-slit experiment. Observation changes reality. Imagine standing before a tranquil pond, its surface glassy and still, a perfect mirror of the sky, until you pick up a pebble and toss it gently. Ripples radiate outward, overlapping, interfering, forming elegant patterns that tell the story of impact, motion, and disturbance. Now imagine this. You return the next day, toss another pebble the same way, but this time, before it hits the water, you blink, and when your eyes reopen, the ripples vanish. The pond remains untouched, as if the very act of seeing had prevented the splash. This is the metaphorical heart of the double-slit experiment, one of the most confounding, beautiful, and unsettling experiments in all of science. It begins simply, enough, with light or particles of matter like electrons or photons, and a thin barrier with two slits. Shine the particles one at a time through the slits, and they mysteriously form not two bright spots, but an interference pattern, as if each particle has gone through both slits simultaneously, interfering with itself like a wave. It's as though a single entity splits, explores all possibilities, and then reunites with itself in a mathematical dance. This behavior reveals a deep truth. At the quantum level, particles behave like waves of probability, not localized things, but clouds of potential outcomes. But here's where the paradox blooms like a black rose. If you observe which slit the particle goes through, even gently, without disturbing it, the interference vanishes. The particle no longer behaves like a wave, but like a discrete object, choosing a path and following it. The act of observation collapses the wave function, forcing the universe to make a choice. Reality, it seems, does not resolve itself until watched. This is not metaphor, it is measurement, verified, replicated, and irrefutable. The observer changes the observed. Consciousness, or at least the act of information extraction, bends, the unfolding of the physical world. And this rips a hole through classical assumptions. In Newton's universe, reality exists independently of whether we look. Apples fall, planets orbit, waves crash, indifferent to our attention. But in the quantum world, observation is entangled with existence. The path is not chosen until we peak. The particle is not a particle until we ask it to be. The fabric of reality is participatory. What then is real, the wave or the particle, the possibility or the measurement? The paradox is not merely that light or matter acts as both wave and particle, but that it acts as either, depending on what we choose to see. Reality adapts itself to the question we ask. This is not a quirk of photons. Electrons do it. Molecules do it. Even some large biomolecules, like buckyballs, show wave-like behavior in double-slit setups. The implication is breathtaking. The universe, at its core, does not evolve like a clockwork mechanism, but like a probability field sculpted by inquiry. This leads to deeper, stranger questions. What is observation? Must it involve a human mind? Or is any interaction with a measuring device enough? Some physicists argue that decoherence, the entanglement of a system with its environment, explains the collapse. Others suggest that consciousness plays a unique role, that the mind and the measurement are inextricable. This resurrects the old ghost of idealism, the notion that mind precedes matter, or at least co-creates it. Are we then not just spectators, but co-authors of reality? Every glance a choice, every question a brushstroke on the canvas of being. The double-slit experiment has been called the quantum Rosetta Stone, a window into the language the universe speaks when no one is listening. It reveals that potential is more fundamental than actuality, that what could happen exists more deeply than what does, until the observer compels a resolution. This undermines determinism. It suggests the future is not fixed, but a branching garden of forking paths, and that our participation selects among them. Time itself becomes suspect, not a flowing river, but a network of collapses, stitched together by awareness. The experiment also touches the metaphysics of choice and agency. If the universe responds to observation, then the questions we ask matter. If we collapse reality into form by watching it, then our attention is not passive, it is creative. This collapses the boundary between subject and object, between internal and external. The distinction between out there and in here becomes blurry. The quantum world tells us that separation is an illusion, and that interaction defines existence. Philosophically, this upends materialism. It challenges the idea that the universe is made solely of things. Instead, it hints that the universe may be made of relationships, of information, of choices between outcomes. Even the language we use, particle, wave, observer, begins to fray under the weight of such mystery. The experiment is simple in form, but infinite in implication. It suggests that reality is not something we stand apart from, but something we are immersed in, tangled within, shaping and being shaped by it. Like a dream that only solidifies when remembered, the quantum world is a fog of probabilities, until attention crystallizes it into form. And yet, this is not an invitation to solipsism. The world pushes back. There is structure, law, and predictability. But within that structure lies the ghost of freedom, the possibility that each moment contains not one outcome, but many, not one truth, but a superposition of truths waiting for resolution. The double-slit experiment does not give us answers. It gives us mirrors, mirrors in which we glimpse the strangeness of being, the idea that knowing and being are woven together. That reality is not just what exists, but what is experienced. That questions are not just ways to extract knowledge, but engines that bring universes into focus. In conclusion, the double-slit experiment is more than a demonstration of quantum behavior. It is a philosophical invitation, a spiritual riddle, a scientific koan. It says, you are not separate from what you see. Your questions shape the answers. Your attention sculpts the real. The world is not merely out there waiting to be catalogued. It is with you, of you, responsive, reactive. A universe that flinches when you look. That dreams itself differently under your gaze. And in that realization lies both humility and awe, that to see is not just to understand, but to participate, and perhaps to create.